Let's get started with writing our first Python class. So first of all, you need Python installed and you need to be able to write a little bit of Python to make use of this module and to make use of Python 301. So in front of me here, I just have VS Code. It's just a simple text editor. You can use PyCharm, you can use brackets, you can use any text editor you like. I just happen to like VS Code. So in front of me here, what I'm going to do is go to View and then go to Terminal and just open up that terminal. And that's just going to give me a terminal at the bottom and my file viewer on the left. Let's go ahead and create a new file here and let's call this firstclass.py. So let's take a look at writing our first class. But before we do that, we need to take a look at some of the syntax. So when we're writing a function, it's like something along the lines of def function name do a thing. A class is a little bit different. Now to instantiate a function, we simply say the function name, and that's it. Now a class is a little bit different. A class starts with the word class, and this is going to create what's known as an object. And in Python, everything is an object. A file is an object, a function is an object, a class is an object, but they're managed slightly differently. So a class starts with a keyword class, and then we typically give it uppercase naming, or at least capitalized words or capitalized letters. So we say something like class, this is an animal. And that's literally all there is to creating a class. And then to instantiate that class, or to use less fancier terminology, to activate this class, we say animal is equal to this is an animal. Now, at this point, this class is completely useless, but this will work. This won't give us any errors, and we can demonstrate that by going into our terminal and typing python firstclass.py. We don't see any errors. That means this is working the way we want it to work. If you don't see errors, that's a good thing. So let's go ahead and create a real-life example here. So this example is going to be literally just an animal example, and we're going to use this example through pretty much all of this Python 301 module or this course. So let's go ahead and create a brand new class. We say class, we give it a name, colon, and then we can do something in here. Now in the next few lessons, we're going to talk about properties, methods, and things like that. But for now, let's go ahead and give this a simple property. And this is really just a fancy word for a variable inside of a class. And so we have something like a property, and this is actually keywords. We're not going to use that. We'll use like property1 is equal to something. Then we can instantiate this class or activate this class by saying the animal is equal to an animal class. It has the parentheses there, a lot like a function. And then we can say print the animal dot property1, and you can see it autofills for me using VS Code. And so this is a lot like a dictionary object, but a dictionary looks something like this. It's looking up a keyword. In a class, we use dot notation, and the dot simply means this is going to be some sort of class, and this is some sort of property or a variable inside of that class. Let's go ahead and run this. And we see that it says something, whatever this is in here. Now we can overwrite that, and we're going to talk about that in future lessons. We can completely change that. We don't have to use property1 at all. We could literally name this anything else. So I'm going to select this, go to view, or is it selection? Selection, add next occurrence. And that's going to select both of these so I can write in two places at once. And I can say, this is a property. And when I run this again, it's simply going to print out the word something. And so you can see that these two, even when I click it, they're highlighted at the same time. These are married. And so to make sense of this, we created a class called animal, gave it a property, just a boring, bland property. We hard-coded it, so it's actually not a lot of use right now. There's not a lot of use for it. Then we instantiated that class and we threw it in a variable. And by doing that, we activated this class or instantiated this class. Then we said in that variable, activate the property. This is a property. Now, right now, this is a lot like a dictionary. The syntax is slightly different, but this is a lot like a dictionary. So what I would like you to do is create an example animal class, or really any sort of class, give it a property, hard code the value, activate that class, and then print out that property. So essentially do what I did in this video. When you're done that, let's head on over to the next lesson where we talk about class properties a little more in depth. Welcome back. In this lesson, we're going to be talking about class properties. So to carry on from our last lesson, I'm simply going to copy and paste what we have from our previous lesson, which I just renamed from the last video, just so it's a little easier to manage these files when you download the source. But I'm going to basically take this exact code and move it into this next lesson. And I'm going to do this moving forward through Python 3.01. So in the last lesson, we talked about this being a property. We have a class, this is a property, and this is hard-coded to be the string something. Now this doesn't have to be a string. This could be a Boolean, a list, a dictionary. It could be literally anything. But let's make use of something that's a little more complicated. So let's make use of a dictionary. So we're going to have a property in here. It's going to be set to some form of a dictionary. And in here, we could say key 1 is then equal to value 1. And then we have to instantiate that. We did this in the last lesson. We use the variable after the animal class has been instantiated. This is a property, and this is going to print out a dictionary. So if I run this, it prints out a dictionary. Now we know that this is a dictionary, and at this point, this is just a standard variable. There's nothing special about this. It just happens to be that there's a class here, then a property, consider it a variable. And then to access a key, like we would in a regular dictionary, we just give it the key name, and that matches right here. So when I save this and rerun the script, we can see it says value 1. And so we're going to see this a lot in professional level Python. We're going to see properties set as dictionaries. This is a very common thing. And so it's going to be really useful for you to know that this is a class, this is a property, and this property, its data type, or its structure, is a dictionary, which means we can then look things up. But it doesn't have to necessarily be a dictionary. We could say this list, and I'm just going to give it any name, is equal to a list of maybe names. So we've got Cain, Caleb, and Gully, who is a cute little cat. Actually, he's not little, he's a pretty big cat. And then we could say, print the animal, this list, and when we rerun this, we're going to see down here, it says Cain, Caleb, and Gully, and it shows up as a list. Now, because this is a list, we can do indexing and slicing and stuff on it, just like a regular list variable. It just happens to be it's inside of a class. That's really all there is to it. So if we wanted to get, let's say Gully, remember lists start at 0. So this is 0 index, 1 index, 2 index. We'd say this list, hard brackets, 2. And this is going to print out the word Gully or the name Gully for us, just like that. Now, when it comes to automatically assigning properties, we can do that with this thing called a Dunder method, a double underscore method. We're going to talk about that in its own particular lesson. We can also use functions as properties, and that gets to be a little more advanced. We're going to talk about that in the next lesson. So in this lesson, what I would like you to do is create a class, give it 2 properties, and instead of just using a string or a number or some sort of simple data type, use a new type of data type, or not a new one, but a more complex data structure. So the first one should be a dictionary, and the second one should be a list, and then try to access that dictionary and list from within the class. Now, a fun thing we can do, because in other programming languages, we have these things called private properties. Python doesn't have private or public. It's all just sort of accessible. So what we could also do is print animal dot this list. And that's just simply going to, instead of throwing the class into a variable, we're going to access this property by its class directly. So if we go ahead and run this, we're going to see prints out our list for us, as we expect. So there is no private, there is no public, nothing like that. I know PHP and Java and all these other languages have that. Python doesn't have that. Oh, and one more thing, actually, I should not forget this. You're going to see this all the time. Whenever you see a property start with an underscore, like this is a private property. So this is how we get away with it in Python. Instead of saying this is going to be private, Like in some languages, we literally use the word private. We start with an underscore. And when we start with that underscore, we're simply saying this is a private property. Don't access it from outside of the class. So don't access it this way. It should only ever be used internally. Now, we don't know how to use those internally yet, so we're going to learn about that in the next couple of lessons. But what I would like you to do is go ahead and give this a shot. Try this out. Create an animal class, dictionary, list, private property, and then instantiate your class, print something out from your dictionary or list, and then try to print just straight from that animal class, one of the properties without instantiating it and without throwing it straight into a variable. So there's two ways to do this. Go ahead and give that a shot. Try it out. Please try it out. This is important because when you get into the world of, for example, machine learning or even just Django web framework, you're going to see classes everywhere. It's important to know how classes work in Python. Thankfully, they're pretty easy to learn. So in the next lesson, let's go ahead and talk about class methods. Hello, hello, hello. In this lesson, let's go ahead and talk about class methods. Class methods, honestly, it's just a fancy term for a function inside of a class. And so it looks exactly like a function. There's only one distinct difference here. So let's go ahead and get rid of this private variable. That's just from the last lesson. And let's create a new method. So this is a method. This is all there is. And this looks exactly like a standard function. And so all a method is a function inside of a class. Now, one thing to note here is that on a standard method inside of a class, its first parameter is always self. Now, if you come from like a JavaScript background, you're going to see this, or PHP uses this as well. PHP uses something like this. I think it's $ this and then an arrow. JavaScript uses the this keyword. In Python, we use the self keyword. And what that does is when we say self, we can now print self dot, and we have access to everything. And you can see VS Code has automatically filled this for me. We have self dot, this is a method, this is a property, this list. So let's go ahead and print this list. We've written a method here. Now let's go ahead and activate it. And to activate it or to run it, we're going to instantiate this animal class because this is a best practice. Instead of accessing animal on its own, we throw it into a variable. Then we say, the animal dot. This is a method, parentheses. And unlike a function where we see a keyword argument or a required positional argument in here, like self, we don't have to do that. We can simply ignore it. So even though self is used inside of the class, outside of the class, we completely 100% ignore it as if it doesn't exist. And that's just saying because this is a class object, inside of here, it's going to have access to everything inside of the class. And the reason we do that is so that we don't have to constantly put in new arguments. So we wouldn't have to say this list, this is a property, etc., etc., etc. We don't have to constantly pass these things in because we would have to put in a list here. And then this next one is going to be a dictionary. They're already set in here. We don't have to pass those in. So I'm going to undo that and simply run this as a method, print self this list. And again, self is referring to animal, this list, property, class, property. Let's go ahead and run this. Python 301, lesson 3, class methods, and it prints it out for us. So with the self keyword, we have access to other methods, other properties, all that other good stuff inside of this class. We don't have access to other classes yet. It's only this particular class, and that's what self is referring to. Self is referring to the animal class that we are working in. Next up, we can also define properties using methods. And again, to boil this down into more layman's terms, we can create a class variable based on a class function. So let's go ahead and create a function or a method called getGully. It's going to take self as its first parameter, always does, and we could return, because it's basically a function, self.thisList, And then gully is number 2. It's index 2. 0, 1, 2. Now, when we try to get this, we're going to have to say get gully with parentheses. Now, if this is supposed to act like a property instead of a function, let's say there's nothing in here and it's just supposed to return a simple piece of data, we can use this thing called a decorator, which we'll talk about in the future as well. And we just say at property. And what this is going to do is say any sort of logic in here, any logic. And this method could get huge. There could be 100 lines of code in here if we wanted to. It's always going to put this into a property. And when this is a property, we ditch the parentheses. Now, because we're using the return keyword, just like a function, this isn't actually going to do anything. This is a method up here is actually printing. In this case, let's make this a little more complex. Let's use a method like a regular function and actually return something. So then we could say gully is equal to the animal get gully, and that's going to allow us to use this later. So we could print the cutest gato of all time is gully. Let's go ahead and run this. And we're going to see that this prints two different things. It's going to print this is a method because it's executing this, which is going to print. And then we're going to print the cutest gato of all time is gully. And look at that. It prints our list just like it did in the first example. In the second example, in our second print statement, this is our class. This is our property. And you can see it actually looks a lot like a function, but it's got a decorator on it basically saying, hey, even though this is an executable object, or what we call a callable, treat it as if it's not a callable. Treat it as if it's a standard property like this list, and this is a property. And because we use the return keyword, it's going to be able to then throw that into a variable, any variable name, and then we can use that variable down the road. Now let's take a look at one more example. Let's create an example where we add a name to this list. So in here, we can say def, because we're going to create a method, add name. It's always going to take self, and then name is going to be the parameter that we're going to add. Then we can write self.thisList.append that name. And we can, if we wanted to, return either self.thisList as the entire new list, because all we did was take a list. If you forget about the self for just a second, it looks just like a regular list, list.append. This just happens to be accessing it from outside of the function or the method. So we have class, property. It's a list, so we can use .append on it. We're going to append the name here. And then it's going to return this list for us. And we're going to see this a lot. So let's go ahead and comment out that code. And let's say the animal dot. And what did we call it? We called it add name, and it takes a name. Ignore self. Self always goes in there, but we ignore it. Add name, and then the name is going to be rhubarb. Then if we wanted to, we could print the animal dot this list, and we're going to see that this list now has Cain, Caleb, Gully, and rhubarb. So we're dynamically adding things to our properties now using a method. Let's go ahead and run this. And it says Cain, Caleb, Gully, and rhubarb just as expected. And again, all we're doing here is we're using data types, standard Python data types inside of a class. And so we're encapsulating, or, to boil that down because we like our big words as developers, instead of encapsulate, think of it as contain. So all we're doing is containing all of this code in a class. And the idea here is that we're grouping functions and variables, or methods and properties. We're grouping them together in this thing called an animal, this class called an animal. And the idea here is that all of these are related somehow. So what I would like you to do as your task for this lesson is create a class animal, create a property, make it an array, or make it a list, a Python list. Then write a method to not add something, but to delete something from that list. So instead of @name, it could be called remove name. Remember, it takes self as its first parameter. 100% of the time, it always takes self. Inside of this particular method, we can then access self dot whatever your list is called dot remove, and then the name. And then down here, we can say, well, we instantiated it. This is our class. This is our method name. So yours would be called remove name, and then the name to remove. And then you can print out that entire list again and see that it was actually, in fact, removed. In the next lesson, let's go ahead and clean this up so this looks a little more like a real world example, because right now this is messy code and this is just tutorial code. This is no good. Let's create a real example of an animal class in the next lesson. All right, taking off from that last lesson, what we're going to do is clean this up a little bit and create somewhat of a real animal instance, or sometimes we call a class an instance because it is an instance of a class. But we're going to basically get rid of all of this, and we're going to create a proper animal class. So what kind of things does an animal have? An animal has a fur color, and let's say that fur color is going to be orange. Then an animal also has actions it can take. What kind of action can it take? It could def eat. It could do something. And remember, we always put self in here. We could also do def chase because it's going to chase down its food. Let's say this is like a tiger or a cheetah or something. And this is also going to take self as its first parameter. Then we instantiate this class. Let's call this tiger is equal to an animal. And then we can make that tiger, we can make it eat, we could make it chase, we could print out its fur color, or we can make it, let's do this, def speak. It's going to take self, and this is simply going to print rar, rar, animal dot speak. And so when we run this, when we run Python, lesson 4, class cleanup, it's going to print out rar, just as we expected. Now this is nothing that we haven't covered already. And if you're just stepping into Python 301 and you're sort of new to Python and you're just wondering what this pass is, this simply means don't do anything but allow indentation. Because if we don't have this pass in here, let's go ahead and see what kind of indentation error we're going to get. We get an indentation error. Expect an indented block after def chase. Actually, it's looking for it in here, doing its best to figure out where it is, but we simply put pass in there. Now, this is a very generic class, and there's honestly nothing super useful about this, but in the next lesson, we'll talk about class inheritance. So there's no task for this lesson. I just wanted to show you that I'm going to clean this up a little bit. In the next lesson, we're going to extend this animal class, and we're going to create, let's say, an actual tiger or a different type of animal. And then we can overwrite the speak method, the eat method, chase method. We could add all sorts of things to it. So when you're done watching me clean up this code, let's head on over to the next lesson where we talk about class inheritance. Class inheritance. So one of the really nice things behind Python, or I guess really any class in any language, it doesn't have to be Python, but the nice thing about a class is that we can extend it. And so instead of just saying class animal and then have another class called tiger and another class called house cat, we could, instead of having to write speak, eat, chase, fur color over and over and over again, we can simply extend it. And so what I'm going to do here is get rid of this and create a new class. And this one's going to be called tiger. And in brackets, it's going to extend animal. And I can type pass in here to literally do nothing. And it's automatically, because it's extending this animal class up here, it's automatically going to get the fur color, speak method, eat method, and chase method. So what I can do is now write tiger is equal to a tiger class, tiger.speak, and instead of writing animal is equal to an animal class or tiger is equal to an animal class, we can now say tiger is equal to a tiger class and then the tiger speak. So let's run this code and let's see what happens here. We're on lesson 5 and it says rar. Now just for fun, let's go ahead and print this out. Let's see what kind of type this is. Print type tiger. And it's going to say rar, but it's also going to say main tiger. This is different from animal. If we swap this out for animal, we're going to see that well, it still says rar, but the class main animal. And so we swap that out. Now, what's nice about this is we can overwrite everything in here. So instead of saying speak rar, we could say something else. Def speak, it takes self. And what is this tiger going to say? They're great. Like Tony the tiger. Get it? Okay. Maybe not the greatest joke I've ever made. But let's go ahead and run this. And we're going to see that, actually, let's get rid of this line. We don't need that anymore. When we run this, it's no longer going to say rar. Because we're instantiating the tiger class, it has speak. Its inheriting class, it also has speak. Which one is this going to run? Well, because we're instantiating the tiger class and we're overwriting speak, it's going to run this one. So it's going to say, they're great, as expected. Let's go ahead and create one more example in here. Let's create a house cat class. House cat. It's also going to extend from an animal. And when we overwrite speak, we're going to make it say, meow. And that's all we're going to do there. And instead of tiger speak, we can still keep that instantiated if we wanted to. It's not doing anything, so we could actually delete it. But let's show you an example where we have both a tiger class and a house cat class. So we could now write cat is equal to house cat.speak, and let's also write tiger.speak. And one's going to say they're great, and the other one's going to say meow. And let's go ahead and run this. And it says they're great and meow. Now at this point in time, you're probably thinking, well, this is no good. I mean, I might as well write a regular house cat class and not extend from animal if I'm overwriting the one thing I'm using anyways. If that's what you're thinking, yes, you're absolutely right. Let's go ahead and look at that fur color though. Let's print cat.fur color. And we're going to see that this is orange. They're great, meow, and it says orange. But we can overwrite that. We can say the fur color is equal to black. Let's save that and rerun this, and it's now going to say black. And so by default, it inherited orange as its fur color, just as a default, so it's kind of like a blueprint. And then we changed that fur color for this particular house cat to be black. Now, essentially what we're doing here is we're creating some sort of blueprint with this class, and this is called an interface. In the next lesson, we're going to talk about interfaces and sort of what they are and how we implement them and the reason we even write them. But for now, what I would like you to do is create a class called animal. You might already have one. And then I want you to extend that class. I want you to inherit that class by writing class, your new class name, extend animal by putting animal in brackets here in parentheses, and then you can overwrite its attributes or its properties. You can also overwrite its methods. And then I want you to instantiate that house cat or whatever animal you choose to use. And then whatever method you chose to overwrite, whether it's speak, eat, maybe something brand new, maybe it's something that's outside of what you've seen in this module so far, I want you to execute it. Cat.speak is going to print meow. And then I want you to, as you have overwritten one of your properties in here, I want you to also print out that property. And so here I just did print cat.furColor. And again, it's really, really important that you learn how classes work, because in frameworks such as Django Web Framework, we're going to be using a lot of classes. And it's important to know that even if you didn't know what animal had, let's zip that up there, just collapse that. So even let's say you don't know what's inside of animal, you would be able to somehow overwrite what is inside of animal. You would be able to explore and figure out, oh, an animal has a fur color, but I want to overwrite that. It has a speak method. Oh, yeah, it's got a default speak method, but I want to overwrite that too. So when you're done that, let's head on over to the next lesson where we talk about class interfaces. Let's have a conversation around what an interface is. So essentially, if you wanted to boil it down, a class interface is literally just a blueprint. And so all it's saying is there's going to be some sort of property. There are going to be some sort of methods, or just a method, And it's simply supposed to implement something. And in the last lesson, we created a tiger and a house cat. Let's go ahead and just delete these just for a second. We'll create new ones. And let's work with just this animal. And typically when you see an interface, you're going to see that there's some sort of method and it's just going to pass. Or you're going to see something like raise not implemented error. And let's give this a better example here. Let's extend animal. Let's do class houseCat is going to extend the animal class and simply pass. Let's then instantiate that houseCat. So we could say houseCat is equal to houseCat, or cat is equal to houseCat. And then we could do cat dot. And which one did we overwrite here? Well, we didn't overwrite anything, but we know that it's going to automatically inherit speak from the animal class. So let's go ahead and speak. And let's run this file. This is lesson 6 class interfaces. And it says not implemented. Now the idea here is that you simply have a blueprint, and that when you use this, you're supposed to implement this. If you want to use it, you have to implement it. And so to get rid of this not implemented error, or if it's just pass and it's returning none, we could simply say def speak. It's going to take self as its one and only parameter, mandatory parameter inside of a class. Print meow. And so what this is doing here is it's saying, hey, houseCat is going to use the animal interface, or this blueprint. If we try to use speak, well, there's nothing implemented, so we have to implement that. And because we extended animal, we overwrote speak so that this no longer works. So you can kind of think of it like this. We take these two lines, and it's a lot like this. Boom, we simply replaced it. But the interface, or the blueprint, is simply meant to tell us that it's supposed to be implemented. So when we save this and rerun this, we're not going to get a not implemented error. We are now going to get print meow as expected. And so that's pretty much the only role of an interface. An interface is a blueprint that says, hey, if you want to use the speak method or any method, you have to implement it yourself. But just so you know, whenever you extend from it, houseCat will always have the speak method. And it's our job as developers to overwrite it. Now, your task for this lesson is to create an interface. So if you already have an animal class, if you've been following along with Python 301, you probably have an animal class already. Go ahead and instead of using speak, go ahead and raise a not implemented error on eat or chase, or another function or method of your choice. Extend that class or inherit that class, create a new one. I just created one called houseCat, and then overwrite that method. You might have already done this once before. It's not a bad idea to do it again. This time we're implementing an interface with not implemented error. Next up, we're going to talk about the super function. So a lot of the time you're going to see with classes that because we can extend a class, you're going to be able to access a function above it. So think of this as below and animal is above. And so if we think of this as a hierarchy, which is how I like to think about it, we are simply overriding speak, which is what we did in the last lesson. But if we wanted to, we could execute whatever is in here. So instead of overriding speak, let's overwrite eat. So in our animal interface, let's go ahead and print I am eating yum, yum, yum. And because we're extending houseCat from animal, we can now instantiate that houseCat and we can say eat. And we've done this a few times already, so we're not going to see anything new in here. It says, I am eating yum, yum, yum. And even though houseCat doesn't have a eat method on it, the class it's inheriting from, animal, it has it. So we're allowed to use that. Now, let's say we wanted to overwrite the eat method, but we also wanted to execute the code that's in here. Let's do two examples here. Def eat self print I am eating salmon. And when we re-execute this, cat.eat, well, we've overwritten the original eat interface method. And so all we're going to see now is I am eating salmon. But what if for some reason we wanted to also execute this? What we could do is we could sort of bubble it up. So remember, this is the bottom, this is the top. we could bubble up to the animal class and execute eat. Now there's two ways to do this. There's the right way and the wrong way. The wrong way is to write animal.eat. Because this isn't instantiated in a variable yet or anything proper. I mean, we can access it technically, but really we shouldn't do it this way. And then the right way is to simply say super, it's a function, dot, eat, and if there are any sort of extra parameters in here, we just simply match the parameters. We don't have any parameters, we don't have to pass in self. It's in a class, it already knows that self is being passed in automatically. And so what this is going to say is, get the class that's above it, the animal class, that's what super is doing here, and then execute the eat method. So it's going to get that animal class, then that eat method. And then it's going to execute it for us, because we said eat with parentheses right there, execute it. And so it's going to print I'm eating yum yum yum, and then it's going to print I'm eating salmon. Let's go ahead and save this and give this a try, and we're going to see it does exactly what I'm describing here. I'm eating yum yum yum, I'm eating salmon. And so all this did, again, was bubble up to that animal class, execute.eat, whatever is in here, could be a print statement, could be anything. It will execute everything in there. And then we wrote whatever else we wanted. And again, this could be any logic that you want to write whatsoever. It doesn't really matter that it's a print statement. It could be mathematics. It could be a web scraper. It could be anything you want. Now let's go ahead and do one more example with chase, but let's add some keywords in here. So in our animal class, we have def chase self. And what are we going to chase? We're going to chase a gazelle. That's what we want to chase. So let's chase an animal. And this is going to print, I am chasing an animal. And let's make sure that animal by default is a gazelle. I hope I'm spelling that right. Maybe not. And when I go down here, cat.chase is now going to, because we haven't implemented it yet on our own, it's coming from the interface, it's going to say I'm chasing whatever the animal is, which happens to be a gazelle by default. Let's go ahead and run this. And it says I'm chasing a gazelle. Now we can also pass in a keyword in here. The cat might be chasing a mouse. Let's go ahead and run this. And it says I am chasing mouse. Funny English there. I'm chasing a gazelle or a mouse or something like that. Now to implement chase, we can we can write def chase self animal. It's going to match what we see up here. The animal by default is going to be a gazelle, but we're always going to pass in an animal, so we're not going to make this a keyword argument. We're then going to say super.chase. We're going to pass in that animal up here, whatever that's going to be. So it's going to say I'm chasing by default a gazelle, but maybe the animal is chasing a mouse. I'm chasing a mouse. And then we could print animal was caught. And we could use f strings if we wanted to, or just a regular print statement. It doesn't really matter at this point. These are just examples. Let's go ahead and run this. And this is going to run cat.chase, which is here. It's going to super up to this one. It's going to say I am chasing a, whatever the animal is. By default, it's a gazelle if it's not provided. And here we're saying it is required. Then we're going to pass that in. Let's go ahead and run this. And it is missing a keyword in here. So let's go ahead and throw mouse as a keyword in here. Not a keyword, but a required positional argument. Let's go ahead and run this one more time. And it says I'm chasing a mouse. Mouse was caught. And so chase is now doing whatever the interface is telling us it's going to do. We then bubbled up using the super method or the super function. We said, hey, wherever this is extending from, whatever class it's extending from, use that. Then run the chase method, and we simply passed in animal. So animal is actually doing a lot of traversing here. We passed in animal as a string here. It's going to then go into here, then going to go into here. It's then going to be overwritten here. So instead of gazelle, it's going to be mouse, and we're simply going to print it. So we're moving data around quite a bit. And this is very common in Python. It's actually common in all class-based languages. So that all happens before it even gets to print animal was caught. And then it prints animal was caught. Now, this is somewhat of a tricky concept to wrap your head around. So what I would like you to do is create a brand new interface class. You can call it animal, I would like you to write it from scratch, just as good practice, you know? So create like an animal interface, make it chase something, and it simply does a thing. Then extend that animal. I extended mine to be a house cat. Yours could be a tiger, a cheetah, an elephant. It doesn't really matter. Just make sure you extend it. Overwrite that chase method and use this super function in it. And remember, super is simply going to say, oh, okay, this is extending from a class, animal. That's our interface. That's up here. And then it's going to say chase. So it's now talking about this animal. That's super. Chase. That's this method here. It's going to then print, I'm chasing an animal of some kind. And then execute some code underneath it. We're just using simple print statements, but you could actually use proper Python logic if you wanted to. You could add numbers, you could scrape a website, you could do pretty much anything. We're just sticking with something fairly simple to get our heads wrapped around the idea of object-oriented programming. Once you've done that, let's move on to the next lesson where we talk about Dunder methods. And a Dunder method essentially lets us take automatic action. And for instance, our animal always has a fur color of orange, but what if we're using an elephant? Well, then we would have to write the fur color in here. I guess is going to be gray. Or we're going to have to take that house cat and we're going to say cat.fur color is equal to gray. And at this point, we're just working with variables. That's no way to live your life. We might as well throw it into here when it's being instantiated. We'll talk about that in the next lesson. Let's talk about Dunder methods. And so what I'm saying here is D-U-N-D-E-R, Dunder. And what this means is double underscore. And so these are magic methods that come with the class. If you're already familiar with classes in another language, you're going to be familiar, for the most part, with Dunder methods, or magic methods as they're called in some other programming languages. So let's move back up to our animal here, and let's create a Dunder method called init. And it starts with def underscore underscore init underscore underscore. It's a method, so it always takes self as its first parameter. And then we could give it any other parameter. And so this could be fur color, and then it can do a thing. And what this allows us to do is in our code down here, which we're extending, we can now put a fur color in here, and that fur color could be gray, for instance. Now, currently this is not going to do anything, but if we execute this code, we're going to see that there is not going to be an error. There's just no error that's going to show up. It's going to be nice. Cool. It's doing exactly what we did in the last lesson. But what we're saying now is we can pass in a positional required argument. Let's go ahead and run this without gray in there, even though init is accepting fur color. And we see missing one required positional argument. Now, let's back this up a second. What is init doing here? Init is simply saying when you instantiate this class, when you activate this class, even if it's being extended or inherited in another class, we now need to pass something in. This is going to be run before any other function. And so whenever we use underscore underscore init, what this is saying is throw in some sort of parameter or parameters or arguments, and that's going to automatically execute. So we don't have to then type cat underscore underscore init gray, something like that. It's just going to automatically do it for us. And so we can type gray in here. And let's go ahead and let's demo that this is going to execute before all of our other functions. Print fur color is fur underscore color, and let's use an F string here. And it says fur color is gray, then it executed I'm chasing a mouse, then it executed mouse was caught. And so there's an order of operations here. Now init is by far the most common one you're going to see. And this just simply means that we can work with fur color. Now by default, that fur color is going to be orange. Let's go ahead and get rid of that. We don't need that anymore. And we can simply, because we know that this is going to be executed first, we can simply say self.furColor is equal to fur color. And what this allows us to do is then use self.furColor in any other method that we want to use, whether it's in the animal class or it's in an inherited class or an extended class. It's going to automatically assign that for us. So let's get rid of that print statement and let's create another method in here. Def get fur color self, and let's simply print self.furColor. Now, for the most part, you can ignore all of these because we're not going to be using them in this video. What we're going to do is create a class, automatically throw in the fur color. It's going to then assign self.furColor. We can then, once we instantiate this class, we can do cat dot get fur color. This is a method, so it takes parentheses. And what that's going to do is, because there's no get fur color method in our house cat, but there is one on the animal interface, it's going to execute this. And it's simply going to execute whatever color we put in here. And just as a better example, let's write this out. Getting fur color. And this is going to say getting fur color gray. It says getting fur color gray. Let's do orange. 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 And it's going to say getting fur color orange. And so what's nice about this is now we can use the super function. So we can say def init on our extended class self fur color super init, and that's going to take the fur color as well. And so anytime we instantiate a house cat, like we're doing down here, we're going to overwrite that init function, this one up here. But instead of just overwriting it, we actually want it to do everything it's doing by default. Let's say we're happy with that logic. We don't want to overwrite it. We simply want to extend from it. So we're going to allow self.furColor to be assigned. And then we can, if we wanted to, print something like fur color was saved to the class object. And then we could do something else in here if we wanted to. But you're going to see this a lot too. In professional level Python, you're always going to see an init, or not always, but a lot of the times you're going to see init, and sometimes you're going to see us overwrite it. And so we're overwriting it here, and we're saying, actually, we do want to overwrite it, but we also want to use the regular logic that comes with it, whatever that may be. And then we want to maybe do something else. So let's say we didn't necessarily want to overwrite the animal type every time. We could say up here, animal type is equal to unknown. And we could force that animal type in the house cat. Self.animalType is equal to house cat. Let's go ahead and print self.animalType. And so at this point, we're now using init, we're using a dunder, we're using super, regular print statement, we've seen that a trillion times already. We're then forcing that animal type to not be passed into init. It's not in there whatsoever. By default, it's unknown. But because it's a house cat, we want to hard code this. We want to say, house cat is always going to be a house cat. No matter what we do, it will always be a house cat. It is not changeable. And so we do not throw house cat in here. We're simply saying instantiate house cat, and it's going to have an animal type of house cat in there. And then it's going to print that out. Let's go ahead and run this. And it says fur color was saved to the class object. That's right up here. It ran super up there. So we we know that self.furColor is accessible. We have access to that in all of our methods. Then we said the animal type is a house cat and print that animal type. And so first print statement, house cat is the second print statement. Where is it? Right there. It says house cat, and that matches down here, word for word, letter for letter. And then we're getting the fur color, and we're saying it's orange. And that's coming from here, get fur color. And we simply set that fur color in init. This is getting to be pretty advanced Python, to be honest. But we're passing it in here, saying self.furColor. And then in a method, we're accessing self.furColor. Now, if you're looking at this video, scratching your head going, whew, I don't understand a single thing that was just said. What I would like you to do is try this out. I want you to try this out until it makes sense, because you're going to see this everywhere, especially in professional level Python. This is very important that we understand both super and Dunder methods. Now, in this lesson, we're really just talking about the Dunder method. And the Dunder method init, as a recap, simply means execute this before every other method inside of our class. We can override it. We can use super on it. We can do anything we want. It's a lot like a regular method, like speak. It just happens to run first automatically, and those parameters get thrown right into the class instantiation. And so now this looks a lot like a function with a parameter. The only difference is this is a class, and this is automatically going to be accessible throughout the rest of our class. I want you to give this a try. Please spend at least 10 minutes on this and just tinker around with it. Even if you can't get it to work, it's good to spend that 10 minutes on it. And just because how brains are designed, even if you struggle with it, it's okay. It's good practice regardless. Go ahead and give that a shot for about 10 minutes. If you don't get this working in about 10 minutes, feel free to move on. You'll have lots of time in the future to practice using Dunder methods and super. Welcome back. Let's stop talking about classes. Okay, we spent something like 8 lessons together talking about classes. And yes, they are important in Python. They're extremely important in Python. But there's another thing that's extremely important in more advanced Python, and that is how we can manage error flow. So we do this thing, try a thing, except another thing. And what this is simply doing is say, try a block of code, and if there's an error, do something else. So it's a lot like an if-else statement. The only difference is it's looking for errors. And so let's take a look at a simple try except. And so the syntax looks like this. We're going to try a piece of code. And so let's try total is equal to 1 divided by 0. Now, if we go into our Python shell and we do 1 divided by 0, we're going to see this gives us a 0 division error. You cannot divide by 0. Mathematically, it's just one of those rules. We're not allowed to do it. So what we can do now is accept any sort of exception, and we can say that total is going to be 0. Print the total. And this is really all there is to a try and except block in Python. The important thing here is that it's going to try a piece of code. If it fails, if it raises some sort of exception, like what we see here, a 0 division error, it's then going to skip this line of code and everything below it. This will not execute. Simple as that. It's then going to pop out of this block and it's then going to try to execute the exception. And so when we run this, Python lesson 9, errors and exceptions. I didn't spell exceptions right, by the way. I have to fix that. That's going to bug me. Exceptions. Better. We see the total down here is 0, and that's because it's getting 0 here. And as an example, let's do this. Print trying 1 divided by 0. Let's move that up to the top. And then let's print something underneath. This will not show up. And let's print one more in here. Exception was caught. Let's go ahead and run this one more time. And it says trying 1 divided by 0. This will not show up, did not show up in our script down here, and it says exception was caught. Now, at this point in time, you should be thinking, oh, geez, where am I ever going to use this? I hope you're asking that question. And if you are asking that question, let's move on to a proper example here. What happens if we ask the user for some input? So ask for a number. We're going to say input, what is a number? Then we're going to make sure that this is always a number. So we're going to say num is equal to, and we're going to cast it as an integer. So no matter what someone types in here, it's always going to be a number. It's going to be a full number. And let's print that. Print num. And when we execute this, what is a number? Let's write 10. And it just says 10. Cool. But what happens if someone doesn't write a number? Well, that's still going to get stored in this variable. We're then going to try to cast that number as an integer. And what if it's not an integer? What if we write Python 301? we get a value error. Invalid literal for int with base 10. Basically what that's saying is it cannot turn a string into a number with the base of 10. But the TLDR, the short story here, is it simply failed. We could not print this out. We couldn't work with this. So what do? We ask for a number. We try to cast that as an integer. If it doesn't work, we can do except all exceptions. We can then say that number is going to be unknown and simply print it. And this is going to allow us to print that number, which it didn't do before because it errored out, and it's going to say unknown. So let's give this a try. What is the number? Python 301. And it says unknown. If we execute this again, give it an actual number, it says the number is 10. And so what this did was it said, oh, actually, we can't manage this value error. Python just doesn't know how to turn a string into a number properly in a way that's predictable for you, the programmer. And so then it throws an exception. We catch that exception and we overwrite num to be unknown. And then we just printed it out. Now this is a really good use case because what if you're trying to do something and it doesn't turn out the way you expect? Now what I would like you to do is try this out. You can either try out the first example, this one up here where we tried to divide 1 by 0, simply doesn't work. Or you can try out this example, which is the one I prefer because it's closer to being a real life example. Ask for some input. Try to cast that number as an integer. Catch the exception, overwrite the number, and then print it out. And the nice thing about this is we are getting into simple error handling and error flow. And again, what's important about this is in our first example, if we look here, our code simply died. There was no way to recover from that. And so all we're doing with a try except is gracefully catching that error and managing it so our script doesn't die, so that our code can continue executing the way it's supposed to execute. Go ahead and give that a try. It's a pretty straightforward example, so this should only take you a couple of minutes. When you are ready, move on to that next lesson where we talk about catching some new exceptions. We're going to catch particular exceptions. Let's talk about catching particular exceptions and figuring out which exception is throwing and how we can manage multiple exceptions. So let's create an example here. And this is just going to be recreated from the last example. We're going to say some sort of number is equal to input, enter a number. Then we can try to change that number into a number because when we ask for input, it always comes back as a string. And we can accept that exception by doing anything we want. And let's just say this number is going to be unknown. And let's simply print the number when we're done with it. Let's go ahead and run this script. This is lesson 10. Enter a number, 10, prints 10. Enter a number, Python. It says the number is unknown. In the first example, we entered a number 10. It came back as a string, and int was able to typecast this to an integer. So that worked perfectly fine. In the second example, we typed Python. Essentially, this is what we did. Now, we can't turn a word into an integer. It just doesn't work. Python doesn't know what Python, the string, is supposed to turn into as a number. Not in a predictable way anyways, so it throws an exception. Now, when that exception is thrown, we said that number is going to be unknown. Now, how do we know what that exception is? We can figure out what this exception is by typing except exception as e, print exception was caught. And then we can print type of e. Let's go ahead and run this again. Let's type Python as our number, and it says exception was caught, class value error, and it's unknown. So now what we can do is we can accept specifically a value error. So we can add another exception in here, except a value error. Print num was not a valid number. And let's try this out. This has multiple exceptions in here. So let's type Python as a number, and it says Python was not a valid number. and then it printed it down here. Python is what we wrote. Could not cast it to a number or an integer. Then we said whatever that value was is not a valid number. Now this is a lot like an if, elif, else statement. So it's going to try something like an if statement. If it then catches this particular error, it's not going to run any other exception in here. It's only going to run this one particular exception. And so now we have a way to deal with a specific value error. What if we wanted to then do something with this number? Let's say num was perfectly acceptable. It was the number 10, and then we wanted to divide it by another number. So let's create a second input. We'll call it num2. Enter a second number, and we're going to divide these. Then we're going to say num2 is equal to int num2, and the total is going to be num divided by num2. Now, if num1 and num2 are both able to be cast into an integer, total is going to run. However, if one of these cannot be cast into an integer, it's going to then throw a value error. We're going to then catch that value error with an exception and print whatever number was not a valid number. And in fact, it might not be num, it might be num2. So let's say num or num2 were not valid numbers. And let's try this out. Enter a number. Let's do 100. Enter a second number, 10. Okay, no errors, that's good news. What if we did the first number to be 100 and the second number is 0? Well, in the last lesson, we tried to divide by 0. We can't do that. And so we can see that the exception was caught. It didn't execute a value error because no value error was thrown at us. So we can't catch that error. But there was another error or another exception that was thrown at us that we can then accept. Then it prints exception was caught, print the type of the exception, and we worked with the number, which we actually don't need to do anymore. We might want to work with totals instead. I don't know. Now, when it prints type E, it says class 0 division error. What we can do is catch that on its own as well. We can say except 0 division error, print. Numbers could not be divided. And let's get rid of that. Let's try this again. Enter a number, 10. Enter second number, 0. And it says numbers could not be divided. There was no value error thrown this time. That means both these numbers, num1 and num2, were both cast into integers perfectly fine. So there was no value error to catch, so it skipped over this. But then it said, total is equal to num1 divided by num2, 10 divided by 0. Well, you can't divide anything by 0. We get a 0 division error. So we said, okay, try to catch a value error if it exists. If it doesn't, let's try to catch the 0 division error. We then caught that 0 division error and printed something else out. And because this one was executed, the generic exception at the bottom was not executed. This code was simply skipped. So Python is going to pick one of these exceptions, whichever one is the right one, and it's going to execute one of these avenues of code. It will always, always, always try to execute this code. And if there's any errors, it's going to check to see if it was a value error, check to see if it was a 0 division error, check to see if it was a general, broad exception of some kind that we aren't explicitly catching. And so at this point in time, we are now catching a value error, 0 division error, or if there's some kind of other error that's unknown to us, we can then work with that. Now, I say try and catch because I come from other programming languages as well. In Python, we say try except. It's the exact same thing, just a different keyword. And you're going to see try except all over the place in professional Python. And the reason for that, again, is because we want to try something. And if there's an error, if we don't try and accept that error, our code is simply going to die. We don't want that to happen. We want it to keep executing. We want it to keep on keeping on. And so we gracefully catch each one of these errors, or we broadly catch every error, every exception, and work with it. And that just means that our code can keep working. It's not going to error out on us. And that means all of our code down here will still execute. And that's good news. Because what if you're building a program like Google's web scraping bot, and it gets to a website and it's trying to scrape a particular email address and verify an email address. And maybe that email address doesn't actually exist. Like it passed, we thought it was an email address, but it's not a real email address. Well, if Googlebot didn't catch that error, it would simply die, and then someone would have to go and restart it. And you'd have someone at Google all the time just typing Python scrape internet, Python scrape internet, Python scrape internet, Python scrape internet. And our job as programmers is to, if we can, automate ourselves out of a job. And so it's going to then maybe try to get an email address or another website. It's going to then try to do something. And if it can't, maybe it skips it. Maybe it tries a different chunk of code. Maybe it tries to do something else. And then we don't have someone at the other end of a computer typing Python scrape internet.py, Python scrape internet.py, Python scrape internet.py every time it errors out. It's just automatically going to handle it for them. And that's the power behind try and accept, is you can accept any sort of error. These ones just happen to be keyword errors thrown exactly from Python. We can create our own as well if we wanted to. And then we can gracefully handle an error. And that means our code will run forever without any problems. Now, what I want you to do, I want you to try this out. Write some sort of example, and you can steal my example if you like, where you try some code and you accept one error, one specific error type, then you accept another error type, and then you accept just a general error as E, and make sure you print out type E so that you can, deal with that later. Go ahead and write this complex try accept block, and when you are ready, let's head on over to that next lesson. Good luck, and I'll see you over there. Let's talk about decorators. Now, if we go back to a particular lesson, it's one of these, methods? Yes. We can have this thing called a decorator. And a decorator is simply a function that wraps around another function. And in this lesson, we're going to create our own Python decorator. So let's get out of this and create a new Python file. We'll call it lesson 11, decorators, decorator. So typically we have some sort of function, myfunc. And this is simply going to print, my name is Caleb. Then we can run myfunc like this. This is Python 101 stuff right here. Cool. This works. Very bland, very boring. This isn't in a class. This isn't in a try catch. This isn't doing anything new. But let's say we wanted to write a decorator, which typically looks like this. Decorator has the @ symbol and then the name of a function. And all that's going to do is execute a function called decorator and throw this function inside of it, so that we can execute something before or after automatically. So let's go ahead and create a decorator. And so we can create my decorator, and this is going to take a function, just like myfunc. Myfunc is going to be thrown in there as an entire function, not as a variable, but as a function. So we're passing functions into functions at this point. Then we can create some sort of wrapper. We typically see the word wrapper. This is very, very common. Print, do something here. Then we can execute that function, whatever that is. Print, original function is finished. And let's simply return the wrapper. And so this is a function inside of a function. We actually saw this, I think it was in Python 201, where we could put a function inside of a function. And this was essentially a decorator at that point in time. And so what we're saying here is my decorator is going to take a function as its only parameter. It's then going to register a new function called wrapper. It's going to do a thing, execute that original function. We're talking about weird scoping at this point. In JavaScript, this is called a closure. Execute said function, whatever that function is, and then print another statement. Lastly, we return the wrapper. So now there's two ways to decorate a function. Let's go ahead and get rid of this up here because we know that myfunc is simply going to print my name is Caleb. We could call this new function is equal to my decorator. And because it takes a function, we're going to throw in myfunc. Now notice we don't have the parentheses here. We're not executing myfunc. We're simply throwing it in as a function by itself, not as an executed function, just as the function object. Then we can say new func, execute this as its own function. Let's go ahead and try this out. And it says, do something here. My name is Caleb. Original function is finished. And really, this is all there is to a decorator. Now, let's go ahead and do this in a more Pythonic way, a more modern way. Let's cut that. Let's move it up top. And let's decorate myfunc with my decorator. And because we're using this sort of syntax, we don't need to wrap this in here anymore. We can simply write myfunc. Let's go ahead and get rid of that. And let's type myfunc. Myfunc, my function here, is decorated with my decorator. It's going to pass in this automatically. It's going to register wrapper, print a thing, do a thing, print the original function is finished, return that wrapper. Let's go ahead and save and let's run this. And it works the same way. Now this is very Pythonic. I like this way better. You're going to see this way probably more often than not. And all this is the exact same as that first function, or not the function, but the first example. And all we're saying is, hey, use the @ symbol here as a decorator, wrap my decorator around my function. So it's going to execute my decorator, and somewhere inside of there, it's going to execute the original function. And then we can do something before or after, or nothing if we don't want. We could literally do nothing. I mean, that would be pointless of a decorator to do nothing. But we could do something before and after, which makes us really, really powerful. Now, why would we ever do this? Well, because sometimes we have a function and we simply like what it's doing, and we just simply want to add a little extra logic to it, a little extra functionality. And so we don't necessarily always want to change our original function, but maybe we do want to take that original function and extend it. So it's a lot like class inheritance, where we took a regular class and then we inherited it into a new class, or extended it into a new class. This is taking a function and extending it with my decorator. Now this is a very, very, very simple decorator, but it gets the example across. So what I would like you to do is I want you to create a decorator, and I want you to use it this way. Don't use it the function-based way, the original way, which you are going to see from time to time, but this is the more Pythonic way. So create a function, call it my decorator. Its only argument is going to be the function itself, not the executable function, just the name of the function. And so basically we've reassigned a function name as a variable in here. Inside of that, you're going to need to register another function, do a thing, execute that original function, do a second thing, and return that internal function. So we have functions inside of functions. You want to return that internal function. Then create another function, just a regular one. It could be a print statement. It could have some actual logic. It could do anything you want, and decorate it with @myDecorator. Means it's a decorator. MyDecorator simply matches the name of the decorator function. Go ahead and execute myfunc with and without the decorator. For example, if I get rid of that decorator and run this, it prints one line. If I put that decorator back and rerun this, it prints 3 lines. I want you to go ahead and give this a shot. It's not too often you're going to actually create your own decorators. You're more or less going to be using them. But in the possibility that you get into like open source or really advanced Python, then you're going to be creating your own decorators. And it's really important to know how these work and the order that things happen. For example, we have something happening before our function, after our function. Go ahead and try that out. And when you're ready, let's head on over to our next lesson. Welcome back. Let's talk about generators. So a generator is this really, really interesting concept. So for example, if you have a list, so LST is equal to 1, 2, 3. 1, 2, and 3 are going to be stored in memory at all time. Now let's say this list has 10 million numbers in it, which if you're getting into data science, it could have 10 million numbers in it. And you don't want to store all of that in memory because then you have to crank up the RAM on your computer, and your computer is going to need to, well, basically your computer is going to get really expensive if you just throw hardware at it. A generator is a software way of saying, do something with the first number, then do something with the second number, then do something with a third number, and it doesn't care what came before or after it. Now, a generator is typically put into some sort of function. So we could say def myfunc for some sort of number in a range. Range is already a generator in Python 3. So 14, for example. Print num. And when we execute myfunc, Python lesson 12, that's not going to do anything because it's in the function. Let's try that one more. There we go. It says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, not bad. You know, we're only working with 14 numbers. This is not technically a generator. But let's say we wanted to do something big. Like, make this always return all these numbers to the exponent of itself. So we would do num to the exponent of num. So for example, 10 to the power of 10, 13 to the power of 13. And instead of return, which is only going to execute once, like let's try this out. That's not going to work. Let's do total is equal to myfunc and then print the total. Shows up with just one number. What if we wanted multiple numbers? What if we're working with really big numbers? Well, instead we could use the keyword called yield. And what yield is going to do is it's going to say, this function is now no longer just a function, it's a generator. It's going to loop through every number from 0 to 13, and it's going to yield whatever that number is to the exponent of itself. Now let's go ahead and print this. And we see when we print myfunc, it is a generator. Now again, remember, a generator is only going to work one number at a time. So in our first example, where it was just a list, it knows about number 0 through 13. And in a technical way, we can access those numbers. But if we're working with really big numbers, we don't want that. Or if we're working with really big data sets, we want to use a generator, so it's only dealing with the task at hand. It's not dealing with anything that came before or is coming after it. And so the idea here is you're now writing code that's memory performant. So if it's doing 14 to the power of 14, it doesn't care about 13 to the power of 13. It doesn't care about 12 to the power of 12. It's simply going to do this once. And when you try to access that number, then it's going to do the math. So it's kind of lazy. It's going to do the math only when it's demanded. It's not going to do it right off the bat. It's not going to try to store all of this in memory. The only thing it's going to do is store 14 to the power of 14 in memory. And then when it moves on to the next number, it's going to do 15 to the power of 15 and totally forget about 14. Now in typical Python, let's say you're doing Python for web. You're not going to see yield a lot, but in data science, you're going to see it a lot. And it's very important that we know how this works. Let's go ahead and rename this from myfunc to myGenerator. And let's get rid of this. And now we can say for num. Let's not use num. Let's say big num in myGenerator. And we saw down here that this was a generator object. We can loop through these numbers and we can print them out. Print big num. And let's go ahead and execute this. Now, this is so fast with Python, we're not even going to notice what's going on. But what it was doing was first iteration, then the second iteration, then the third iteration, then the fourth, fifth, all the way down to the very last iteration. And you notice how these numbers are getting pretty big? It doesn't actually care what came before it or after it. And what's important about this is we can deal with really, really big numbers. So let's do really big number like 50 to the power of 50. And let's see if this possibly crashes my computer. Look at that. It was able to do all of that quite easily. So I guess I was worried about it crashing my computer for no reason. But it was able to do all of this logic quite easily. And so the idea is, when it got up to 49, it only worked on 49. It didn't have to remember what 48, 47, or 46 were. It didn't have to care about what's coming next. It simply said when it was on 49, work on 49 to the power of 49. It gives us this massive number here. And none of this needs to be stored in memory. Whereas if we had a list, we would have to have all of these numbers stored in memory. Now, numbers are small to store in memory, so it's not really that big of a deal. But when you're dealing with giant data sets, especially in things like machine learning or data science, you're going to want to use yield to make sure that your computer doesn't run out of, well, basically thinking power. It's not going to run out of RAM. Now, if you ever wanted access to these, let's say we said, let's just comment that out. And let's say we wanted to get all of these numbers. So all numbers is equal to my generator. And then we wanted to print these numbers for whatever reason. All numbers. Let's go ahead and execute this one more time. And it doesn't give us anything. It doesn't give us these numbers. Instead, it returns a generator object. Now, if we wanted access to these numbers, what we could do is cast whatever this generator is going to return, the whole thing, all of these numbers, we could put that into a list. Let's go ahead and execute this once it's being cast as a list, and we see all these giant numbers in here. Now, at this point in time, when we're casting this as a list, this generator, whatever it returns, all of these numbers is what it's going to return, is going to be stored in this variable called all numbers. So now we're actually saving this for later. Whereas with just a regular generator, our previous example, we're not saving these numbers for later. We're just doing something with these numbers one at a time. But with a list, we said, yeah, okay, process all of these one at a time, and then all the saved values from that yield keyword goes into this list. And that list is going to be stored in memory, so we could work with this list down the road. Now, why we would do this, or where we would do this, is if we're working with big numbers or a lot of processing, it can do a lot of processing one task at a time. It doesn't have to worry about all the other stuff before or after it. And then we can put just the answer into a list. So while the computer is doing 37 to the power of 37, we don't care about that processing. So basically we're saying this is a little more, what's the word I'm looking for here? Temporary. It's a little more temporary. And so, or disposable, that's a better word. It's going to do one thing, and then when it's done, it's going to throw it into that yield keyword. If it moves on to the next one, it's going to dispose of this in memory. It doesn't really care what the last one was. It just cares about the current task at hand. Whereas with a list or any other data type, once we store it in a variable, it's actually being stored in that variable. So to use a generator and then store it into a variable, not really the proper way of using a decorator, not a decorator, but a generator. This is more or less what we're going to use. So really it's a way to do some sort of processing and then throw it away. So we're going to say for every big number in my generator, print it out. And it's going to process 1 to the power of 1, 2 to the power of 2, 3 to the power of 3, all the way up to 50 to the power of 50. And it's going to print out one at a time. It's not going to store all of it in memory. It's just simply going to do one thing at a time. So it's really, really good for disposable code on large data sets. Now, again, if you're getting into web development, you're not going to see generators all that often, to be honest. But if you're getting into data science or machine learning, you're going to see this all over the place. It's a very, very important concept in Python programming. And in fact, we can do one more example here. Let's check out range. So we can say total is equal to range of 50 and print total. And we're going to see that this returns a decorator as well. And actually, it didn't return a decorator. It returned the function range 0 to 50. It is a generator behind the scenes though, and what we don't see is that it's not looping through and creating a list of 1 through 50. What if we did list range 50? We now get a list from 0 to 49 or 50 numbers in total. And so it works the same way as our made up generator does. Now, one thing to keep in mind is once you iterate on one of the generators in here, it's not going to work anymore for you. So let's go ahead and uncomment this. Let's get rid of this example down here and let's rerun the script. And it should print all numbers, but then print is not going to work at all because there's not going to be anything in there. The generator has exhausted itself. It's a one and done kind of thing. And actually, I'm just looking at this code and it's not going to because it's going to create a new generator for every one of these. Let's go ahead and throw this into a variable. So my var generator is equal to my generator. And let's swap this out here for my var gen. And we can see that it prints all of these numbers, but it's not doing anything in here. So this generator, this function, we threw this into a variable. We then said, hey, execute this. So it said 1 to the power 1, 2 to the power 2, 3 to the power 3, 49 to the power 49, all the way through all those numbers, stored it in a variable. That generator then exhausted itself. So if we try to access that generator again, we're going to see that it doesn't print anything. And all it did was print our giant list here, but it didn't print out one at a time. Kind of like that pyramid shape that we saw right up here. It's not going to print any of those because that generator is done. It's a one and done thing. So if we wanted to access that generator again, we have to, in a strangely worded way, access that generator again. And so we do it this way. We said, call it once up here, and then call it again down here. And this time we're going to see different result. We're going to see all these large numbers, and above it, we're going to see this list of numbers. And so one thing to keep in mind with a generator, it's a one and done thing. Once you exhaust that generator, it's done. You have to create a new one. Or not create a new one, that's bad wording, but you have to instantiate or generate a new generator. Once you've created that new generator, then you can do whatever you want with it. But if you try to execute that generator more than once, if it's like, for example, stored in a variable, it's going to be exhausted that first time. It only cares about performing once. It's not like a function. A function you can keep using over and over and over again. A generator is a one and done type thing. All right, let's talk about pipenvs. Pip environments. I'm saying pipenv. And in Python 101 or Python 201, I can't remember, we used a Python command called python-m venv.venv, and then we got inside of a virtual environment, and this created a virtual environment for us. There's another way to do this. There's actually several different ways to create a virtual environment, but another common way is a pipenv. And I personally really like pipenvs because they're nice and simple. And so we're going to do this one in our command line here. Let's make that bigger. Let's get rid of this sidebar here. And so I'm in my Python 301 folder. And first of all, what I want to do is pip install pipenv. And it's going to collect pipenv. And ta-da, I have pipenv. Now what I can do is type pipenv, and it gives me a list of commands. Check, clean, graph, install, lock, open, run, script, shell, sync, uninstall, and update. This is a lot easier than writing python-m venv.venv. Instead, what we can do is type, and I'll clear this off, we can type pipenv install, and this is going to create a pip environment for us. So let's just do pipenv install. Does a thing. And it says to activate your project's virtual env, run pipenv shell. Pipenv shell. And now we are inside of a pip environment. You can see that I'm inside one because it has brackets over here. Let's go ahead and type python-v, and we're going to see that I'm using Python 3.9.0. Cool. That's nice. Let's get out of this by hitting Control D. So CTR plus D. Cancel with Control C, Control D. That exits our pipenv. Now if I want to go back in, I do pipenv shell, and I'm inside of it. Then I can do pip install. Let's say I wanted to install Django is equal to 2 point something. Just let it install. It's getting 2.2.17. Pip show Django. And I have 2.2.17. Now I know on my computer I don't have that version. I have Django 3.1 point something or other. And so this is now completely isolated from the rest of my computer. And you can actually see location of where this is being used. It's in my users folder, calebtallien.local, share, virtual ems, Python 301, that's the folder name, then some sort of hash, lib, Python 3.9 site packages. Cool, let's get out of here with Control D. And let's say we want to get rid of this pip environment. We can do pipenv --rm. And just like that, done. We don't have a pip environment any longer. And so this is a really good way to create an environment and to delete an environment. Now, let's say you have a project using a certain version of Python. There's two different ways to use Python when it comes to versioning. You can use pipenv, and you can switch your Python version, or the way I prefer to do it is with pipenv. And I can do pipenv install -- Python, and let's do Python 3.7. In our last version, our last pipenv, we used Python 3.9. And so let's go ahead and use Python 3.7. Pipenv shell. Let's just clear this. Python -v, and I'm using Python 3.7.2. So there's two ways to use multiple versions of Python. I personally prefer this way because when I'm done with it, I can simply say pipenv -- rm, and that's just going to remove it. Boom, I don't have a pip environment any longer. Now, if we did ls-la grep the word pip, we're going to see we have two pip files. Now, this command is actually going to be a little bit different if you're on Windows. It's probably just dir. You might be able to use grep. You can always just list out everything that's in your folder too. You can do dir if you're on Windows, or ls-la if you're on Mac or Linux. And I've got a pip file and a pipfile.lock. And what this is, the pipfile.lock and the pip file specifies what kind of packages are involved inside of this pip file. Now, I showed you when I do pip install Django that it gave me Django 2.2.17. The proper way to do this would be pipenv install. Let's just create a new pipenv. And let's clear that. Then we can do pipenv install Django is equal to 3.1. And it's installing. Now, the one downside to pipenv is when you are installing things, it takes a couple seconds longer. Now, in my opinion, it's just a couple of seconds for a nice virtual environment. Life is easier this way. Pip is faster than pipenv. Some people have a problem with that, some people do not. Let's do pipenv shell. Clear, pip show Django. And now we have Django 3.1 in here. And we did that from outside of our virtual environment by writing pipenv install, and then the package name is equal to the version. And again, the really lovely thing about this is we can do pipenv -- rm, and it's going to clean up our pipenv for us. This whole folder is going to be deleted, so we're not wasting space on our computer. Now, if you're like me and you're running on a Mac, you might not have that much space, and you might want to delete your virtual environments when you're done with them, if they're just like throwaway virtual environments. I do that all the time. Now, I personally love pipenv. I like it more than a Python -n venv.venv. Venv. It's just a lot to type. It's kind of weird typing too, just because this is going to use the Python version that's on your computer. Now, if I wanted a different Python version in a virtual environment, I could do pipenv install -- Python, and then the version of Python I want. And that's going to work for me. Now, the other way of doing this, using different Python versions, is using pipenv, which is a great way to use different versions on your machine as well. But I like to localize my project so that everything is inside of a virtual environment, because what works on Python 3.4 is not going to work necessarily on 3.9. And if I have a project using Python 3.9, but my computer only has Python 3.8, oh, now I can go ahead and use pipenv install -- Python 3.9 and get that up and running. Now, as a little caveat, you might need pipenv installed. If you need pipenv, you can go and look at how to install pipenv on your computer. It's going to be a little bit different depending on your operating system, but I'm going to leave that in your hands because you are now an advanced Python developer. Essentially, what I'm saying is you have the skills to figure this out on your own. And the whole lesson really is there's multiple ways to do multiple virtual environments. We could do pipenv, we could do Python -m venv, we can use virtualenv, we can use Docker, we can use Vagrant, we can use all sorts of different layers of abstraction. I personally like pipenv. Now there's no task, I just wanted to show you this. I just wanted to show you that this is an available option for you. Moving forward in our next, it's not even a lesson, it's our final project. We are going to be creating a banking app using classes. Alrighty, welcome back. Let's go ahead and create a final project. Now in this project, what I want you to create is a banking app. And it doesn't need to be super complex, but it does need to have a few little extras in it. So first of all, this should be class-based. It should have methods in it for withdrawal and deposit. And after every withdrawal and every deposit, I want you to write the transaction to a Python file. Now, we didn't cover how to open and write to files in Python 3.01. That was a Python 2.01 thing, if I believe correctly. So what I want you to do is I want you to try creating a project that's going to ask the user over and over and over again what they want to do. Do they want to withdraw or do they want to deposit? And how much do they want to do? Then I want you to keep track of all of that inside of a class called bank. After every transaction, write that transaction to a Python file so we have a history of that transaction. Or not just that transaction, but all transactions. Now, I'm not going to give you any more clues other than we're going to be using while true, we're going to be using input, we're going to be using classes, methods, and properties. This should make your brain sweat. This is hopefully all brand new stuff to you. Well, classes, methods, and properties should be brand new to you. Input, you should know. While true, you should know. Oh, what else do you need? You need to know open syntax for managing files. You should already know that one too. If you don't, definitely go and research how to create this. Now, what I want you to do is try this on your own. Don't watch the rest of this video. I'm going to show you how I do it. I've never built one of these, by the way, so you're going to see all the errors that I maybe make as well. But if anything here is new to you, you don't know how to do it, you can't remember, I'm going to ask you to not refer to another video. Try the best you can. And if you get really, really stuck, go to Google, go to Stack Overflow, and look for your answer on there. Because 50% of coding is solving problems, and you need to learn how to solve problems on your own. If teachers always hold your hand, honestly, you're not going to learn. And I want you, as my student, to actually learn. Not just watch this because it's like a tutorial style Netflix, you know? I want you to actually be able to create a Python app, and then, you know, maybe one day we can actually work together. How cool would that be? So go ahead and create a banking app from scratch. Remember, it's going to have to ask the user for a withdrawal and an amount, or a deposit and an amount. Keep track of all of that. What I'm going to do is fade this out and fade back in, and I'm going to show you my solution. All right, so first of all, I'm going to call this project.py, and I'm going to select all of that, comment that out, and use that as a guideline for what I have to do. So the first thing I need is some sort of banking app. I need to create a class called bank. And what is my initial amount going to be? Well, I'm going to do def init self, and the initial amount is going to be 0. That's how much I'm going to open this account with, $0. And let's use a float here, 0.00. Self.balance is equal to initial amount. Then I need to withdraw and I need to deposit. So def withdrawal self amount. I'm going to take that balance, self.balance, and let's move this up. Self.balance is equal to self.balance minus the amount. Now, what if this amount is, let's say, a string for some reason? We could say the amount is equal to float amount. Now, we don't actually know if this is going to work or not. So what we can do here is, oops, what am I doing here? Try to cast that as the amount. Accept a value error, and that amount is going to be 0. And then we're going to set that new balance. We also want to do deposit. Def, deposit, how much? It always takes self. It's going to take an amount. We want to do the same try and accept here. Try. Amount is equal to float, amount. Accept a value error if it cannot cast that amount to a float. And let's change that amount to 0. Self.balance is going to be the self.balance plus whatever that amount is going to be. So either we're adding to our account or we're adding nothing to our account. And when we withdraw, we're either taking away from that account or we're taking nothing away from that account. Let's make this one step smaller here so we can kind of see this in one view. And now let's go ahead and instantiate this. Let's do account is equal to bank. What does it take in its init, initial amount? Let's say I'm going to open this account with $50 in it. 50.00, no, 50.50, let's do that. Then I can do account.deposit. And let's say I want to deposit $10, or yeah, $10 in there. And then let's print out my total amount. Account.balance. And then let's say I want to withdraw $14.75, not with a comma, but with a decimal. And let's print out that account balance again. Let's make sure we spell that right. Thank you, VS Code, for showing me a typo there. And let's open up our terminal and run this. And so we started off with 50.50. We added 10, so we got 60.5. That's good. And then we took out 14.75. So 60.5 minus 14.75 is 45.75. So that seems right. I'm not going to check that math. I'm pretty sure the computer knows what it's doing. And now we need to add transaction log. And what else do we need to add in here? Oh, we need to ask the user for input. So I'm going to make this one step smaller. I accidentally hit the wrong button there. One step smaller. And let's do another method in here, def log transaction self, and then some sort of string. What are we transacting? What are we doing here? And let's just call this transaction string. Now we need to open a file, so we can say with, that's using a context manager here. We can say with open transactions.txt. We're going to append to it all the time or create a new file if it doesn't exist. As file. Then we can say file.write. What do we want to write? We want to write the transaction string. And let's maybe always append a new line at the end. So let's use an F statement here. Not an F statement, an F string. And throw a new line in here. And that comes from Python 201, where we learned how to deal with files. So now after every withdrawal, we can simply say, if there is an amount, remember, if if the amount is 0, this is going to be false. So this is not going to execute. So we can say if amount, then do a thing, self.log, log transaction, and this takes an amount, or not an amount, but a string. It takes the transaction string. So let's call this withdrew. How many dollars? The amount. Let's do the same thing with deposit here. And what I can actually do is copy that. And we just have to make sure that we swap out this. Always be careful when you copy and paste. So we're going to say the balance is equal to the balance plus whatever amount whenever we deposit. Log that transaction. We didn't withdraw. We deposited the amount. And let's go ahead and open up our files here on the side. And we don't see transactions.txt. Is that what we called it? Transactions.txt. We don't see that in there yet. Let's go ahead and save this and run this, and let's see if there's any typos or anything. And okay, cool. And it deposited amount. I did something very wrong there. What are we doing here? First of all, that's an F string. This isn't JavaScript. That's an F string. This isn't JavaScript. Let's go ahead and run this again. We see transactions. Oh, look at that. Deposited $10, withdrew $14.75. Let's also add the balance in here with a new balance of self.balance. And if I make that just a weensy bit smaller here, we can see that A, I have a typo, and B, that I'm using an F string. And in fact, we could get fancier with this. We could say something happened, and instead of a new balance, we could do tab, tab, tab. Balance is whatever that self.balance is. Let's go ahead and clear out transactions.txt, and let's run this once more. Check transactions.txt. Deposited $10, new balance 60.5. Withdrew $14.75. New balance is $45.75. Okay, this is looking pretty good. Now we need to create a loop of some kind to ask the user for input over and over and over again. Let's close that down. And we have all of our logic working, so let's go ahead and wrap this in something called a while loop. While true, do a thing. What do we want it to do? We want to ask for an action, is going to be input. What kind of action do you want to take? Then we can say, if action is in a list of withdrawal or a depositor, I don't know why I wrote that, then do a thing. So then we can say, if action is equal to withdrawal, amount is going to be, what kind of amount do we want? Input. How much do you want to take out? And then we can do account.withdrawal the amount. And I'm not worrying about typecasting here because we're doing it in here. Nope, not there. In here and in here. Then we can say else, because that action is either going to be withdrawal or deposit. If that's going to be a deposit, how much do you want to, let's say, not take out, but put in? And account.withdrawal is going to be account.deposit. Deposit the amount. And then down here we can say print your balance is account.balance. Now we need to instantiate this before we get into the while loop so that we're not creating a new account every single time we iterate through the while loop. And let's get rid of that, and that, and that, and that. And so now we have an account object, and we're going to either withdraw or deposit and then print out the balance. Let's see how this turns out. What kind of action do you want to take? Let's say I want to deposit. How much do I want to put in? Let's say I want to put in $13. My balance is now $63.50. That's correct. What kind of action do I want to take? What if I want to withdraw? How much do you want to take out? Let's say 13.50, so that gives us an even 50. And let's quit with Control-C. Oh no, we get a keyboard interrupt error. And that comes from this action line. Let's try this. Try, except, and what was that called? That was called a keyboard interrupt error. Nope, it was just called keyboard interrupt. Let's copy that. There we go. And we're simply going to break out of this loop. Let's go ahead and try this out. What kind of action do I want to take? Let's cancel. It simply canceled for us. We could even say print leaving the ATM. And let's put that on a new line. And put that on a new line. Let's quit. It says leaving the ATM. And I gracefully left using a keyboard interrupt exception. Cool, this is coming together quite nicely. Now, one last thing we need to consider is what if the action is not withdrawal or deposit? Let's do this. What kind of action do I want to take? Say I want to rob the bank. it's not going to do anything. This is a bad user experience. It just keeps asking, which I guess is not the worst user experience, but it's not a good user experience. So we can zip this up or collapse it, and we can say, else, if the action is not withdrawal or deposit, what do we want to do? Print. That is not a valid action. Try again. Now let's do this. Let's say we want to rob. Not a valid action. Try again. Rob it. Okay, what if we want to withdraw? That's a hard word to type. Withdraw without a space at the end. How much do I want to take out? Let's say I want to take out $900. My balance currently is minus $849.50. So now I'm getting into overdraft. And if you wanted to, you could extend this to overdraft and loans and, all sorts of things. But that is essentially the entire project in a nutshell. And when I cancel, it gracefully cancels. It doesn't just error out. It says I'm leaving the ATM. So let's recap what this looks like. We have a class called bank. When you open up an account, how much are we putting in there? By default, $0. I put in $50.50 to begin with. Every time there's a transaction, we're going to open up the transactions.txt file. Let's go take a look at that. And it's showing me everything in here. That's great. That's doing exactly what I want it to do. For every transaction, whether it's a withdrawal or a deposit, we're going to take that file, we're going to write to it, whatever that transaction string is. So withdrew or deposit the amount, tab, 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 balance with the balance in there. Cool, simple transaction logger. Then we've got a withdrawal method. We're going to try to cast this as a float. If we cannot cast this as a float, it's going to say the amount is 0. And if the amount is greater than 0, basically as long as it's not 0, we can take some sort of action. We're going to automatically change that balance from whatever it currently was. So I opened up with 50.50, and it's going to minus the amount that comes in here. And then we're going to log that amount and that withdrawal. Lastly, we have deposit. Same thing. We're going to try to cast this amount as a float so that we can do numerical math on it. If we can't, it's going to say that amount is 0. If that number is in fact a proper number, if that amount is a proper number, we can then change that balance to be balance is equal to balance plus whatever amount. And then we said in our transaction logger, deposited the amount. Lastly, we created a new account. And then we said, walk up to the ATM. Essentially, that's what this is saying here. While something is true, just keep asking. Keep asking and asking and asking. Action, what kind of action do you want to take? If we said Control-C, if we canceled, we get a keyboard interrupt error, and we're simply going to leave. We're going to break out of this loop. Otherwise, if the action is in withdrawal or deposit, take action here. And if that action is withdrawal, we can say, how much do you want to take out? And then withdraw that amount. Otherwise, if it's not withdrawal, we know it's going to be one of these two. It's withdrawal or deposit. We know that this is withdrawal. So by logic of reduction, this has to be deposit. Then we say the amount is going to be input. How much do you want to put in? Account.deposit the amount, which is going to work all of its banking internals. And then we can print out our balance, account.balance. Otherwise, if someone is like trying to rob the bank or do something else with the bank that they really shouldn't be doing, we're going to print that is not a valid action. Try again. It's going to then execute that loop one more time and go over and over and over again until you leave the ATM. And that's really all there is to this particular project. And we're making use of a lot of different things we learned in Python 301. We're not necessarily using everything. We're not using a generator. We're not using a decorator, although if you wanted to, you could figure out a way to add those in there. And if you wanted to, you could probably turn log transaction into some sort of decorator to decorate withdrawal and deposit with, so that we don't have to explicitly write it in here. That would be pretty cool if you could do that. And what else do we talk about? Pipenvs. We probably should have done this in a pip environment, but you know what? We're not installing any packages, so we didn't need a pip environment for that. We just needed regular Python on our computers. And we didn't use a generator because we didn't actually need to use a generator. A generator would be really good if we were looping through like 1 million different customers in our bank, and we needed to figure out which customer to find. So that's all there is to this particular banking app. If you didn't give this a try and you just watched right through this video, please go ahead and try this out now. This is really, really important because it's great practice using a class. Don't forget, if you have questions, you can always join the Learning to Code group on Facebook. We're happy to answer any Python question that you have in there. First thing first, let's talk about what is a schema. So you've probably used Microsoft Excel, you've probably used Google Sheets, or some form of program that looks a lot like this. And this is really all there is to a database. I'm going to explain that in this video. So in a relational database, which is what Postgres is, MariaDB is, MySQL is, and SQLite, there's a bunch of other ones as well, but those are, I think, the four most common, MariaDB and MySQL basically being the same thing. So in a relational database, we have these things called columns and rows, just like this. We have columns and we have rows. And so the idea here, and you've probably already used a program like this, so you've pretty much already created a database before. But all it really is, up here you have a name. So instead of column A, B, C, D, E, am I able to rename that? Nope. So let's pretend the first row is going to be our column name. So in a schema, we have these things called columns, rows, and tables. And you know what? Actually, what I'm going to do is I'm going to back that up quickly, and I'm going to describe what a sheet is. So a sheet here is actually a table. So we'll call it table underscore 1. And underneath, I can add another sheet. This is going to be table 2. In databases, we call them tables. In programs like this, we call them sheets. So I can go to table 1, whatever that is. Maybe that table is called users. And in my users table, I might have a column for a unique ID, maybe the name, the username, profession, and then, maybe a hash for a password or something. So that would be my column names. So a column called ID, a column called name, a column called username, and a column called profession. And then underneath, I would have ID 1, name is equal to Caleb, username is equal to Caleb.Tallien, profession, teacher. And then I can have another one, another row of data. So ID might be 2, name is going to be Gully, username is the cat, and profession, he is a cat, and so on and so on and so on. And this can go down for millions and millions and millions of rows. Now this whole thing together, your columns, your rows, your tables, which are basically just different sheets, all belong in this thing called a schema. And this is a schema. And so what a schema is, it's not quite the database. The database would be like Postgres. It would be the actual program. A schema is simply how you set up like a little mini database inside of it, where it's going to know where all the relational data is. And so inside of the schema, you can have multiple tables. And you don't just have to limit to 2. You could have, and I've done this before, and I've actually built these out by hand, you can have hundreds of tables inside of a single schema. And so table number 2 might look a little bit different. Table number 2 might not be users. Table number 2 might be called course lessons. And this would be something like course for the first column. Second column could be called lesson, and there could be an ID in there. Usually ID is at the very front. So can I maybe just move that over? There we go. ID is at the front. Bold and underline. And you'd have ID 1 for the first row. Typically that's in there. Not always, but typically it is in there. Course called SQL 101, lesson number 1, schemas. And then you could have a second one in here, and you could say it's the same course, or maybe it's a different course. Let's say it's SQL 201, and this is going to be lesson number 1 as well, but this one's not going to be called schemas. This one's going to be called foreign keys. And so now what we have here is 2 different tables under the same schema, that's this whole thing here, with different pieces of data. And so that's all there really is to a schema. Moving forward, we're going to be working with actual SQL in a service called SQLite Online. But why was this important to know? This was really important to know because every table you work with has columns. Every table you work with has rows, and you need to be able to access rows by a unique identifier. You need to be able to insert data, such as the name Gully or the username the cat. You need to be able to select a particular row based on a unique ID, such as number 2 here, and then you need to be able to delete it or update it. And that's what we're going to start doing right away in the next lesson. All right, welcome to lesson number 2. We are going to be using a program called sqliteonline.com. So you can go to sqlite, online.com. And this is a free service. Now, if for some reason this service doesn't exist while you're watching this video, and from time to time, websites, they go up, they go down. If this one is just down or doesn't exist for you, you can always find another one. In Google, all I did was type interactive database in a web browser. And I found this one, and this one's pretty good. And so on the left here, we have SQLite, MariaDB, Postgres SQL, MS SQL, Oracle's not currently supported at the time of recording, Docker, syntax, and business. So what we're going to do is we're actually going to close up SQLite, and we're going to go over to Postgres, and we're going to click connect. Because SQLite is a lot like Postgres. Postgres is just a lot more powerful. Now, all the commands you're going to be typing in this course are the exact same for SQLite, MariaDB, and PostgreSQL. Now, I'm just going to zoom in just a little bit here, just so we can see a little bit better. Now, with this service, if you want to, you can sign in, you can create an account. I'm not going to. I'm just going to show you exactly how I do this. Just gonna wing it and show you exactly how I do this from my own personal experience. But before we get started, we have to look on the left here. We selected PostgreSQL, we connected to the database. We have a table in here, we know about tables now, called demo. And in here we have these different columns. We have an ID, which is an integer, a name, and a hint. And we can actually see these laid out in front of us. We have an ID, 1, 2, 3, 4, 5, all the way down to 20. We have different names and we have different hints in here. So we can actually perform a little bit of logic or take an action based on whatever the name is or the hint is or what the ID is. So in the next lesson, we're going to go ahead and select just certain bits of data in here. Let's go ahead and jump right into this and select a little bit of data. So how this looks is it looks a lot like you're reading a book. So we say select and then a column name, and we could do a second column name from the table name, which is going to be demo over here. And that's it. Now this isn't going to work because column name and column name 2 doesn't work. They don't exist. Not that it doesn't work. Well, it's not going to work because they don't exist. So if I go ahead and click run up here, we're going to see column name does not exist. And we're going to get this Postgres error. What we can do is, first of all, we can do an easier way. We can select a star, so select all from demo. And as a shortcut, I'm just going to hit Shift Enter in order to run this instead of having to go up here and click run every single time. So Shift Enter, and I select all from demo. Now, if I only wanted to select, say, like the ID and the name, and I didn't care about the hint, I could do that as well. I could select ID, name from the table called demo, and I can run that. And I'm going to get just the ID and just the name. Or if I wanted just the name, we could get just all of the names. And so that's what the syntax looks like. It says select your column name, which can be all of them, from your table name. And this just happens to be called demo. We'll create a new table on our own down the road. So what I would like you to do is give this a try. Select all from demo, and you should see everything. And then go ahead and just do select ID from demo. And you should only see these IDs in here, 1 through 6. Okay, let's talk about ordering data. So sometimes we don't want everything to be in Postgres's native ordering. So in here, it's ordering by ID 1, 2, 3, 4, 5, 6. What if we wanted to order things in alphabetical order under the name column? We could do that. We could say select all from demo, keyword, order by name, and then we could say descending or ascending. So we're going to stick with descending and go from reverse alphabetical. So Shift Enter to run this, and we get TSLLLL, and then it goes by the second letter. So limit timeout, limit overrun, limit DB. So TODC, and it is now ordering in reverse alphabetical order on the column name. And you notice the IDs are different too. It goes 1, 2, 3, 6, 4, 5. We could also say ascending. So let's make this sort or order by the column name called name in alphabetical order. So I go ahead, hit Shift Enter, and you can see that the IDs have changed again. It's 5, 4, 6, 3, 2, 1, and it is in alphabetical order, going from the least alphabetical, or what it thinks is the least alphabetical. Least alphabetical? That's a funny way of saying it. Lowest in the alphabet to the highest in the alphabet. And we could do the same thing with other columns too. We could say, instead of ordering by name, we could order by the hint. Let's go ahead and hit Shift Enter on that. And it orders by numbers and then letters. And if we ever wanted to do the reverse, we could always say, just order by hint, or whatever column name you want, descending. Now, what I would like you to do is select all from your demo, order by your ID. Make sure that it shows up in reverse order and regular order. So it should say 6, 5, 4, 3, 2, 1. And then when you try it again in regular order, it should say 1, 2, 3, 4, 5, 6. Let's take a look at how we can select specific rows of data, because right now we're selecting everything. We're saying select all columns from the demo table. And we know that we can select certain columns, but what if we wanted to select certain rows? Well, what we could add here is this thing called a where clause. So we could say select all from demo where, and then you take a column name such as ID and you say it's equal to something. And so this is a lot like standard programming at this point, and sort of, this is actually quite Pythonic in the sense that we can just read through it. So select all from demo where ID is equal to, say 5. And we just want to get this because there's a hint of 300, whatever that means. And that's what we want. So if we go ahead and hit Shift Enter, we get 5. Now let's go ahead and undo that. And what I'm going to do here moving forward is, because I don't really like this light theme, I'm going to go over here into the settings and go into skins, I'm going to dark. And that just seems a little easier to read, doesn't it? Now, what if I wanted to grab a row where the name in here is test? What I could do is say, select all from demo where name is equal to test. Now this should break for me. And it says column test doesn't exist. It doesn't know what it's looking for here. So when we wrote a number, we didn't use apostrophes around it. But when we write a string or a sentence or a word, we use an apostrophe around it. So we put in apostrophe test apostrophe. And that finds it for us. Versus what we did before where we said ID. So we could say where ID is equal to 1. It doesn't need an apostrophe. Numbers don't usually need apostrophes in most programming languages. Though, is this going to work if I put apostrophes around it? I'm going to leave that up to you to find out on your own. So what I would like you to do is select all from your demo table where your column name is equal to some sort of value. Or to be more specific, what I would like you to do is I want you to get row number 4. So try to get it by its ID, and then try to get it by its name, and then try to get it by its hint. Go ahead and give that a try. When you're ready, let's move on to the next lesson, where we're going to learn how we can select multiple items in a range. Let's take a look at grabbing multiple rows from a range. So let's say, because in the last lesson we said where ID is equal to 1, this only gives us one particular row. What if we wanted to have a bunch of rows? What if we wanted to say grab all the rows that are greater than the number 3? We could say, select all from demo where the ID is greater than 3. Go ahead and run that, and it grabs ID 4, 5, and 6. So it's grabbing anything where the ID is greater than the number 3. There's another way we can grab a range of things. So let's just go ahead and show all of our items in here. Let's say we wanted to grab row with ID 1, 3, and 5. What we could say is select all from demo where ID is equal to 1, or ID is equal to 3, or ID is equal to 5. Let's go ahead and run this, and we're going to see that only IDs 1, 3, and 5, those rows are going to show up. And just like that. So what it's saying here is if the ID is 1, or the ID is 3, or the ID is 5, then show that data. Now, if we did something weird like, or ID is equal to a big number and it doesn't exist, we're still going to get the exact same results. It just doesn't give us that row because it simply doesn't exist. So it's going to give us everything we are looking for. And if it doesn't exist, it just doesn't give it to us because there's no data for us. Now, we're not going to get into this too much right now, but if you wanted to, you could also say and. So you could say, select all from demo where the ID is 1, and if there were multiple rows with the ID of 1 and it gives you a bunch of them, you could say the ID has to be 1 and the name has to be test. And if we run this, it's going to give us this particular row. Now, this is the exact same as saying where ID is equal to 1, only because there is only one particular row with the ID of 1. But if there were numerous of the exact same pieces of data in there, we might want to filter it. And we filter a little further by saying and. So we say where the ID is equal to 1 and that name is equal to test. If we said where the ID is equal to 1 and the name is equal to test doesn't exist and we try to run this, we get absolutely nothing. There's no data in here whatsoever. And that's because it's looking for ID 1, which it found, but that name column didn't match. So what I would like you to do is, first of all, don't worry too much about the and operator here. Go ahead and just play with the or operator and try to use something like greater than or less than. So you could say, select all from demo where ID is less than 5. And that's going to give you 1, 2, 3, and 4. In the next lesson, let's go ahead and talk about how we can order this data so that, maybe our data is in alphabetical order based on the name column while we're filtering. But first of all, go ahead and give that a shot. Alrighty, there's going to be a time in your life where you're going to need to get specific data in a specific order. So what we could say is select all from demo where the ID is greater than 3. Now, this is going to work if I type it right, where ID is equal to 3. There we go. And it gives us ID 4, 5, and 6. Now, what if, for some reason, your application required you to have ID 654 because you're looking at doing something in reverse? Well, what we can do, and we already learned about this, is we can say order by ID descending. And all we do is we tag that onto the very back of our SQL query. This whole thing is called a query. So we select all from our demo table where the ID is greater than 3, and then we take all of that data and we order it by the ID in reverse ordering. And it gives us 6, 5, and 4. Now, this isn't really useful at this point in time. You actually need an application for it to be working. So maybe just tuck this in your back pocket for now and save it for later. But I'm going to show you one more example here. So we're going to say where ID is greater than 1 and ID is less than 5. So let's go ahead and see what this returns. We get 2, 3, 4. Then we can tag on order by, and let's say we wanted to order by the name in alphabetical order. We could order by the column name called name in alphabetical order or ascending order. And there we go. We have ID 432, it just happens to be it's in that order, but it's also in alphabetical order by the name column. So limit DB, limit timeout, and server. Go ahead and give this a try. I want you to use the and operator this time, and I want you to order by either ascending or descending, and you can order by any column name as long as it's noticeable. So if you notice that you're ordering by the ID descending and it's the same as name descending, try ordering by hint descending or ascending and see what that does to your data. You should see that your data, the first row is going to be different, the second row is going to be different, third row is going to be different, and they're going to flip around a little bit. So go ahead and try that out. When you're ready, let's head on over to the next lesson. All right, let's talk about limiting data. So let's go back here and delete all of our code or our query, and let's just show all of our data. So let's say we wanted to limit our data set. So maybe, for instance, this wasn't 6 rows. Maybe this was 100,000 rows of data, and we don't want to store all of that data. We don't even want to access all of that data. That's a lot of data, and there's not really a good use case for the average person to be needing 100,000 rows of data. So what can we do about it? We can say limit and then a number. So we can say like limit 2, for instance. And what this is going to do is just give us whatever it thought it was going to give us from select all from demo, limit to 2 rows. So what we could do is we could mix a lot of this together. So we could say select all from demo, where the ID is going to be greater than 2, and the ID is less than or equal to 5. We can do less than or equal to as well. Order by ID ascending. And let's first of all take a look at what we get here. We get 3, 4, 5. And if we only wanted the first row, if we only ever wanted to get the first one in here, we could say limit 1. And that gives us our first row of data. Or if we just wanted the first 2, we could say limit 2. And that gives us the first 2 rows of data. And so now we're slapping on a where clause, an and operator, an order by clause, and we're limiting the number of results that the database is going to give us. What I'd like you to do for this particular lesson is select all from demo, where ID is equal to something or other, or not equal to, because that's only going to give you one particular row in this instance, where ID is greater than or less than or greater than or equal to or less than or equal to some sort of value. I want you to order by another column name, either ascending or descending, and then limit that value to 1 or 2. And just take note that this is how we can make sure we only get one particular piece of data. So if we only ever wanted that first row, we can always get that first row. And what this is really good for is, for example, we could say select all from users. We don't have a users table, but if we did, we could say select all from users, where username is equal to Caleb, limit 1. Now, ideally, there would only ever be one username called Caleb, but what this is going to do is say, hey, SQL, I want you to select data from the users table where the username is Caleb, and as soon as you find that first one, just exit. Exit early. So don't scan 100,000 rows if it finds username is equal to Caleb on row 2. It's going to stop at row 2 when it's doing its search through all of its, think of it like a Google sheet. It's searching through all the different rows. Once it finds its answer, it's going to stop. Go ahead and try that out, and when you are ready, I'll see you in the next video. All right, let's take a look at how we can add some data to this table, because right now we're working with 6 rows, and that's going to be kind of limiting in the future. And honestly, if you have 6 rows of data, you probably don't need that to be in a table in your schema. So let's go ahead and add some new data. But first, let's look at the syntax. So the syntax looks like this. We say insert into demo, that's going to be our table name. And then we insert the column names here. So let's insert name and hint. And the values are going to be Caleb. And I put this in a string, so it's got apostrophes around it. And the hint is going to be your teacher. Now, you notice I didn't put ID in here, and that's because ID here, can I inspect that? I can't really see that, but I know that this happens to be a primary key and it's auto-incrementing, which means when you set your schema up, you can actually tell your ID row to always add to whatever the latest one is. So the latest one is 6. This is automatically going to add in ID 7 for us. So let's go ahead and insert into demo. Let's add a name column and a hint column, and then those values are going to be Caleb and your teacher. Let's go ahead and hit Shift Enter. And it looks like it did absolutely nothing, and that's just because it's looking at our queries right now, the query that we have in here. I can comment this out by using --. You can see it changed text there. And now I can write select all from demo. And there it is. It shows up in there. If I wanted to, I could run both of these side by side. All I need is that semicolon at the end. So I can insert into demo, select the name column, the hint column. These are going to be in order. This is going to be the name column and the hint column. Let's go ahead and add Gully, and the hint is going to be Big Cat. And I can hit Shift Enter, and this is going to run both queries. It's going to run this one, and then it's going to run our select all from demo. So let's go ahead and try this out. And we can see at the bottom here, number 8, Gully, is a big cat. That's how we insert data. And that's literally all there is to it. It's insert into your table name, then in parentheses, we use which columns we want to insert into, followed by a space. Then we say the values of those particular columns, which has to match here. So we say name is going to be Gully, hint is going to be big cat. And all we have to do is hit enter, or run, or shift enter. We just have to run this code. And then after that, we said select all from demo. And that's just going to show all of our code in here. Now I can run this once more, and you're going to see that Gully shows up twice. He's got ID 9, ID 10, ID 11. So there's a lot of duplicate data in here. The only thing that's not duplicate is the ID. The ID is auto-incrementing, so it goes 8, 9, 10, 11. Go ahead and insert some data into your demo table. And when you're done that, let's go ahead and take a look at how we can update some of this data in here so that it's not all duplicate data. In the last lesson, we created a bunch of duplicate data. So column, or row with ID of 8, 9, 10, and 11. These are all the same. And so let's go ahead and update row 8 so it doesn't say Gully and Big Cat. Let's update that so it says something different. So the syntax for an update clause is a little bit different, or an update query rather. And so it looks like this. We say update the table name, which is going to be demo. That matches right over here. Then we set the column name that we want. So let's say we can set the name is equal to rhubarb. And if we did this right away, this is going to change all of our data in here, which is not what you want. You don't want to overwrite that. So be careful with it. What we want to do is we want to update just ID number 8. So we could set name is equal to rhubarb, where ID is equal to 8. So let's go ahead and run this. And we can see ID 8, first of all, got moved down to the very bottom. That's a Postgres thing. Every time you update a piece of data, it moves down to the very bottom. So ID 8 is now rhubarb and big cat. Which is true. He's a big cat, but his name is rhubarb. It's not Gully. What we can do here is we can say order by ID ascending, and that puts it back in order for us. And if we wanted to, we could say update. Actually, let's comment this out. We could say update demo set hint is equal to orange kitty, where our name is going to be rhubarb. And so this is going to find all instances of data where the name in our name column is rhubarb, such as in ID 8, row 8. It's going to find all of them, and it's going to update them to say the hint is orange kitty. Let's go ahead and run this. And there it is, rhubarb, orange kitty. Now let's go ahead and change Gully to big cat to a black and white cat. So we can change all of those all at the same time too. We can say update demo set hint is equal to black and white cat. And let's not use quotation marks. Let's use apostrophes for that. Some databases are a little bit specific about that. I think, if I remember correctly, Postgres is one of those databases. So you don't want to use a quotation. You want to use an apostrophe. So let's set the hint is black and white cat, where the name is going to be Gully. And this is going to update all instances of Gully. Let's also do select all from demo, where the name is Gully. So we're just going to get the Gully information. We're not going to get test and all this other stuff in there. We just want to get Gully. And look at that. The name is now black and white cat for all 3 instances. Now, if we wanted to, we could simply say select all from demo. And it's going to show you all of our data in here. And it says that the name Gully has a hint of black and white cat for all 3. So it did, in fact, do exactly what we wanted it to do. We just limited the data that we were looking for originally, and then we expanded our views so that we could see all the data as a whole. So what I would like you to do for this lesson is update your demo table, set a particular name. I would advise not changing the ID if you don't have to, but change the name or the hint to be something else where that ID is equal to something. So only change one row of data. Don't change all of your data, just change one row of data. Let's take a look at how we can delete data. So let's say we accidentally have too much duplicate data in here. We have row with an ID of 9, 10, and 11. It's all the exact same. So let's go ahead and delete row 10 and 11. How do we do that? First of all, let's take a look at the syntax. How this looks is we say delete from the table name, happens to be called demo, where, and then some criteria. So we could say where ID is equal to 10 or ID is equal to 11. And what this is going to do is it's going to, behind the scenes, select 10 and 11, then it's going to delete it, and then it's going to run this query here that says select all from demo, which is going to give us rows 1 through 9. So let's go ahead and run this and watch these bottom 2 rows just disappear. Just like that, just gone. Now you want to be really, really careful with this, because if you said delete from demo and you didn't add a where clause in here, depending on your database and the constraints on it, you might end up deleting all of the data. So you always want to use that where clause, just like when you're using the update syntax or the update query, you want to always have a where clause so you don't overwrite all of your data. With delete, you want to delete from your demo where specific data exists. So you don't want to delete all of it. Be careful. Now this is just an example website and you can always just start over. File, close Postgres, and then you can open up Postgres again and it'll give you rows 1 through 6 as it did at the very beginning of this course. But in real life, when you're working with a live production database, once that data is gone, it's gone forever. And that makes it really, really scary to use the delete clause. So be careful with this one. So I want you to keep that in your mind whenever you're deleting data. Be careful. And if you're ever wondering, oh, how do I know if I'm selecting the right data? You can always do a select clause first. So we can comment this out. And you can select all from demo where ID is greater than 5, for instance. And we actually need to comment this one out as well. And what this is going to do is give us row 6, 7, 8, and 9. That's all that exists. And you can see that this is the data you do in fact want to delete, which then you could say delete from demo where ID is greater than 5. If this is the right data you want to delete, then you can delete it. That's a good way to confirm how, not how, but which data you want to delete. Okay, let's get into something bigger. Let's go ahead and create a new table. So right now we have a table called demo, but let's say we wanted a new table called store or my store. Maybe you want to make an e-commerce system. Maybe you want to store users. You could create a table called users. First of all, we have to look at the syntax. So let's go ahead and say create table, then the table name, and then we give it a column name, and then it comes with its type attributes, and then a second column name. And this particular website does weird things like column name, type, and attributes are all uppercase, but second column name isn't. Second column name, type, attributes, and a third one, and a fourth one, and a fifth one. And so that's really all we have to do. Now, this isn't going to work because column name, type, attributes isn't the right syntax, but this is what the syntax looks like. It says create table, and then your table name, and then you set up your columns. So let's go ahead and create a new table in here. Let's say create table. Let's call it my store. The first row is going to be an ID, and it's going to be an integer. The second, did I say row? I meant column. The second column is going to be item name, and this is going to be a variable character of 30 characters. And so we're not going to get too much into like integers and varchars and things like that. You can always Google those if you want. We are just going to briefly, very lightly touch the surface of creating a new table. Let's create a product price, and this is going to be a decimal with 5 numbers and 2 decimal points. A notes column, and this is going to be a variable character with 255 characters in it. Items sold is going to be an integer, and let's set the default to be 0. Let's go ahead and run this, and first of all, we're going to need to see if I have any syntax errors in here. If I run this and you see an error, it's because there's probably a typo somewhere. But if this works the way I think this is going to work, over here on the left is going to create a new table called my store. So let's go ahead and run this. And there it is, my store, and it has an ID, item name, price, notes, item sold. Now this isn't going to look like anything at this point in time. So if we did select all from my store, we're not going to see any data in here whatsoever. What we need to do is we need to insert some data. So we have to insert into my store, give this product an ID, an item name, a price. Let's give it some notes. And items sold, we don't want to say that any items have sold. So it's going to have a default of 0. Then we give it values, and that ID is going to be, say the first ID is going to be 1. That item name is going to be a fidget spinner. Do you remember those? And what's the next one in here? We have item name. Price is going to be $1.99. And you notice how numbers and floats, they don't have to be in apostrophes, but strings or words have to be in apostrophes. That's important to take note of. And the last one here is notes. And so that note is going to be, it spins forever. And that's it. Let's go ahead and hit enter, and then it's going to select all from our store, and it's going to show us that we have an ID of 1, item name is fidget spinner, the price is $1.99, notes it spins forever, items sold 0. Now let's just go back, go and back, and let's take one more look at this syntax. So when you want to create a new table using just SQL, it's create table, your table name, your column name, and then what type of column it is, and then any particular attributes, such as like default 0. Comma, column name, type of column, this is going to be a variable character, takes 30 characters, and that's it. Then we have price, it's a decimal, it takes 5 numbers in total with 2 decimal points. Then we have notes, variable character, 255, which I believe is the max for a variable character, although that might be different depending on certain database types. So don't take that as gospel per se, but roughly it's usually 255 is the max for a variable character. And then the item sold, we said this is going to be an integer, and what kind of attributes we gave it. We said it has a default of 0. And so when we added that item in there, we added a fidget spinner, we didn't tell it number of items sold, it automatically just happened to be 0. And that's because we said the default was going to be 0. So that is how we create a table. Now you're not actually going to be creating tables using SQL most of the time. I have very rarely had to write my own SQL this way. There are better tools for this, but this is what the syntax looks like behind the scenes. So what I would like you to do is I want you to give this a shot. I want you to create a new table, and it can be super basic. It can just have an ID and maybe an item name. So it can have just that part in there. Go ahead and give that a shot and create a new table, and then insert some data into your new table. Cleaning out an entire table is a little bit easier than you think it would be. So first of all, if we go back to demo in here, and let's do select all from demo, we could, if we wanted to, delete every single row, but that's a very, very slow process, and there's a better way for a database to handle this. So let's say we wanted to truncate all the data in here. And what truncate means, and I'm saying truncate, it means clean. It means wipe it out. It means start fresh. What it's going to do is get rid of all that data in here. So let's go ahead, and in the line above our select, let's just simply type truncate and then my table name. And I'm going to truncate the demo table. That's the one that comes with SQLite Online. So I'm going to take this whole piece of data here, this whole data set, and I'm just going to get rid of it. So I'm going to truncate it, and then I'm going to select all from demo, and it's going to show up with absolutely nothing. So let's go ahead and run this. There's nothing in there. Let's go ahead and get rid of that truncate and just select all from demo. There's nothing in there. The columns still exist. The setup, the schema still exists. But there is simply no information in here. It just doesn't exist. There's no rows. There's columns, but there's no rows. And that's how we basically clear out an entire table. And so if you're ever like, oh, I have all this data in my sample table and I just want to get rid of it, you can always do truncate and then your table name. And simply, that will just clear out all the data. And it's a lot faster than deleting one line at a time or one row at a time. Okay, last but not least, let's look at deleting a table. So select all from my store. And what I want to do here is I don't want to just delete this data. I want to delete this table so it's no longer in my database. And what I can do here is I can simply say drop table and then the table name. And that's all there is to it. Drop table and then your table name, and that's going to get rid of the table and all the data in it. It doesn't move the data anywhere else. It literally destroys it. And so if we run this, we can see on the left, my store is gone. There's no more data in there. And I can do select all from my store. And relation, my store doesn't exist. We deleted it. So it is gone forever. So just be careful with that. But if you're ever creating like temporary tables to store a lot of information about a particular user or sales information or something like that, you might want to create a temporary table and then delete it later. And that is certainly one way of doing it. Now, what I would like you to do for this lesson is I want you to, whatever your table was, not the demo one, the other table that you created, the new one that you created, I want you to drop that table. So remember, it's drop table and then your table name. Go ahead and drop a table, and once that is gone, let's head on over to your final project. All right, let's take a look at your final project. Your final project is step 1, create a new table. Step 2, insert at least 5 products into your table. Step 3, select 3 out of the 5 of those products. Doesn't matter which 3, just make sure you select only 3. And there's multiple ways of doing that. I'm going to leave that up to you, how you want to do that. And step 4 is take a screenshot of your page and share it with the class. And share it with the class. So pretty easy. I want you to create a new table, insert at least 5 new products into it. And while you're doing this, by the way, you'll get bonus points from me, which actually aren't worth anything. But if you wanted to go the extra mile, you can always comment out your commands too. So your first one could be create table, new table or my table, and then a bunch of stuff in here. And instead of just deleting the line, what you can do is you can comment that line out, and then you can do the next step and screenshot all of your SQL all in one screenshot and share that with the class. That would be a really great way to show people that you are writing all the SQL and that you're not just writing a little bit of SQL here or there and that you're doing all of it. And that's a great way of showing me, your teacher, that you are working on it the way that I want you to work on it. So go ahead and give that a shot, and don't forget, if you ever get stuck or if you ever need help, you can always join the Facebook Learning to Code group. Last but not least, I am Caleb Tolling. I've been your teacher through SQL 101. Thank you for joining me. I hope you had a little bit of fun. I hope you learned quite a bit about databases. I hope I got to show you that they're not that scary and that they're actually pretty simple. And lastly, I hope to see you around in another module or coding class of mine. Thanks for taking SQL 101, and I'll see you around. Bye. All right, welcome to Django 101. Before anything, we need to create a virtual environment. We always do this when we're working with Django, or really any project whatsoever. So in order to write Django, you must know a little bit of Python. If you don't know Python, you probably don't have a text editor. So in front of me, what you see here is VS Code. This is my text editor. On the left is going to be my folder, and at the bottom is going to be my terminal. So if I go over to View, and then Terminal, the bottom is going to be my terminal. And so we are going to create a virtual environment. Now there's a plethora of different ways we can create a virtual environment. We can use Vagrant, we can use Docker, Virtual Env Wrapper, a Python venv, a venv, or we can use pipenv. And in this module, I'm going to show you how we can do it with pipenv. So first things first, you probably already have Python installed. You should be able to do Python-v. I'll be using Python 3.8. If that works for you, you can then type pip install pipenv. Now I already have pipenv installed, so this is going to be really, really quick. This might be a little bit slower for you, but eventually that should be installed. And then we can type pipenv install Django. And this is going to create a new pip environment for us. And we just give that a quick second to install Django for us. And this is going to install Django 3.1. We'll look at the exact version in just a second when this is done. All right, now that that's done, we can do pipenv shell to get inside of our pip environment and do pip show Django. And I'm using Django version 3.1.4. Now to get out of our shell, all we have to do is type Control D, or exit, and that's going to exit out for us. And to get back in, we just simply type pipenv shell. And if we take a look at our files here, ls-la, or if you're on Windows, dir, it's going to give us a pip file and a pipfile.lock. Now at this point in time, if you have git installed, you can do git init, git add, git commit, number 1, setting up a pipenv. And then if we do this real fancy command, which is a fancy git log, you can see that our first commit here is setting up a pipenv. If you're not using git, that's okay. You can simply ignore that part of this video. I'm going to be using git moving forward, but again, if you're not using git, if you're using a different version control system, that's totally cool too. You can just ignore that part. In the next video, let's go ahead and actually get Django set up. Okay, let's go ahead and get Django set up. So first things we need to do is we need to get inside of our virtual environment. Now I'm using pipenv. You can use venv, Docker, Vagrant, whatever abstraction layer you want. It's just good to have some sort of virtual environment in here. If we do pip show Django, we should be able to see we have Django in there. If you don't have Django in there, you can always do pip install Django is equal to 3.1.4 or whatever the newest version of Django is, and that will install Django for you. Next, we can type Django-admin start project, and I'm going to call it my site, and then I type dot, and that's just going to put it right into this exact folder. So let's take a look at where we're at first. I'm on my desktop in a folder called Django 101. We can see that on the left here, Django 101. And so I just simply want to type Django admin, start project, my site. And if you don't give it the dot, it's going to create a subfolder in here called my site, which may or may not be what you want. I don't want that. I just want Django to create a brand new project in this directory that I'm in. Now, if I do ls-la, or if you're on Windows, you can type dir, and we're going to see that we now have manage.py and my site. And if we open this up on the left, we have all sorts of stuff in here. We have a manage.py file, WSGI, URLs, settings, ASCII, and an init.py. Now, what we can do here is we can, if I just clear this off, type djr Django run server. So we type Python manage.py run server on 0.0.0.0 port 8000. And this should say that, yeah, we have unapplied migrations. Now, what a migration is simply, it's connecting to a database of some kind. So I know that it's connecting to an SQLite 3 database here. It's just a simple file. And it's trying to provision my database so that we can set up users and permissions and all sorts of things. And whenever you see this red little, it's not really an error, it's more of a message. It says, hey, you have 18 unapplied migrations. You can simply type python manage.py migrate. And what this is going to do is tell Python, whatever version of Python you're using, to execute manage.py, and its parameter or its argument on the command line is just the word migrate. And so we run that, and we're going to see that all of these are now running. And then to run our server again, I just have this shortcut to djr because I run this command hundreds of times a day. So python manage.py run server 0.0.0.0 :8000. And we should see this. Now, at this point in time, if you see this, we can now open up our browser and we can head on over to localhost port 8000. So we just type in localhost :8000, and that 8000 matches what we typed in our command line, and we should see this. Once you see this, you now have a Django project up and running successfully. Now, this is cool, but there's nothing in here. So let's go ahead and check out the admin. We can, is there an admin link down here? Documentation, tutorial, Django community. There's no admin in here. So we can go straight to /admin, and we need a username and password. So let's go ahead and set up a username and password. Let's head on back over to our terminal here, and we can type python manage.py create super user. And all I did there, by the way, when I was running the server was I just hit Control-C to cancel. So I'm going to create a new super user. I'm going to call it Caleb, no reply at caleb.io. I'm going to give it a password, retype my password, and cool. Super user successfully created. That's our admin account. And then we simply run python manage.py run server 0000 colon 8000 again. Head back on over to our browser, refresh, just make sure this page actually loads the way we're expecting it to load. Type in our username and our password. And voila, we are inside of our Django admin. This is where we're going to be editing all of our content. We can manage pretty much everything through here as long as we tell Django that it's supposed to be manageable by an administrator. So your task for this lesson is to install Django inside of your virtual environment and create a super user. And don't forget to run your migrations. And once you see this page and also this page, you are ready to move on to the next lesson. Okay, let's go ahead and create our first app. And so Django does this funny thing where, actually, I don't know why they call them apps. It's kind of confusing because we're not creating a phone app or mobile app, but it's like a little mini application inside of our Django application. And so we call them apps. And so what we can do here is create a brand new app using a command that Django gives us. So we do python manage.py, and I'm just inside of my virtual environment here. Python manage.py start app, and I'm going to call this feed. And if you look on the left, just give it a quick second, it creates a folder called feed. It has migrations, init, admin, apps, models.py, test.py, and views.py. Now what we want to do is activate this. And in order to activate this, what we have to do is go over to my site, go into our settings.py. I'll make this just a wee bit smaller here. And what we're looking for is installed apps. And here we see we installed apps. Django contrib admin, auth, content types, sessions, messages, and static files. These are all things that just come with Django. We don't need to worry about what they are right now, as this is just a Django 101 course. So this is a list, a Python list, and I'm simply going to type the name of this folder in here. It's called feed. And let's go ahead and run our server once more. And we see nothing happens. If we see that nothing happens, this is good news. This probably means you have installed your feed properly. That's all there is for this video. Hopefully you're following along. Don't forget, you need to run python manage.py start app, not start project, but start app. And then the name of your app. And that's going to create a new folder for you. And then you go into your settings, installed apps, and install that app. Just put it at the bottom of your list of installed apps. All right, let's go ahead and create a new model. And so what a model is supposed to do is not only does it automatically generate a table in our database for us, so Django is very nice in the sense that we don't have to manage our database pretty much whatsoever. It automatically does that through the form of migrations and models. And so a model is simply a way to write code in a form of a Python class, and it's going to automatically map to a database that we can't even see. And then we can go and modify some of that data. So in this lesson, what I want to do is create a new model in our feed, just called posts. And then we're going to activate it in our Django admin so that we can see it. So I'm going to stop running Django. Not that it was detrimental while it was running. There's no problem keeping it running. In fact, I'll show you that it can stay running while we're doing this. So we're going to open up feed models.py, and it says create your models here. Let's go ahead and delete that comment. And let's type class post models.model. And what this automatically does is if we were to tell Django, hey, look for new changes called migrations, it's then going to generate a migration file and then provision our database to make it have a table called feed_post. And that just allows us to create a simple way to store data. Now in this post, we're going to start very simple. We're going to start with some basic text. And so in here we say text as a property is equal to models.char field. And this is just a character field. It takes a max length. And I believe the max length is usually somewhere around 256 characters. But let's make this like an original tweet, like 140 characters. Then you're often going to see another keyword in here called blank. And that can be either true or false. By default, blank is false. And what that means is when we're filling out a form, does this field need to be filled out? Absolutely, yes, it needs to be filled out. We're going to say this is mandatory. And then we have another option in here called null. And null can be true or null can be false. And when null is true, that means our database can store either no value an empty string, or some sort of string. We don't want this to be null is equal to be true because we always want this to be filled out in our database. So there's always going to be text. It can't be blank. It can't be empty text. It always has to be there. So let's say null is equal to false. Now let's go ahead and save this. And you see Django automatically restarted for me here. What I can do now is make a migration. So I do python manage.py make migrations. And this is going to create a brand new file. And you can see in here, it created 0001 initial.py. And all this does is create a Python file that's now executable. And when we run python manage.py migrate, it doesn't have any dependencies. It's the first one, and it has some operations in here. It's going to create a model or create a table in our database called post, and these are the fields. It has an ID automatically, so a unique auto field ID. Every model comes with this, and the one we gave it is text. So now we have a table that we can add to our database with 2 columns in it. And let's go ahead and run python manage.py migrate. And this is going to apply that migration. And now we don't see anything happening at this point in time. All we see is that applying feed 001 initial was okay. That's all we need to know. That's about as much database management as we're going to get into in Django 101. So let's rerun Django run server. And when we go back to our browser here in our admin, we're not going to see anything. And that's because by default, this table exists, but it simply is not manageable yet. So we need to make this manageable. So we created a model which maps to a table. We ran the migrations. We now need to go into feed admin.py, and we need to register our model here. So let's go ahead and get rid of this comment. And this is going to look like this: class post admin, or whatever you want to call it, admin.modeladmin. And admin is just coming from here. We can simply pass. We don't want to do anything. We can give it extra parameters, extra features. We can enable all sorts of features. We're not going to do any of that right now. We just want it to be simply editable. Then we say admin.site.register post and postadmin. And so what this is going to do is connect post with postadmin. Now post is not imported yet. We need to import that. So we can say from, and because this is in the same folder, admin and models are in the same folder, we can simply say .models import post. And when we register here, it's saying connect post with this postadmin, which is going to inherit everything from admin.modeladmin. Let's go ahead and save that. Django's restarted. And let's refresh our Django admin here. And again, once again, I'm just at localhost port 8000/admin. And now I have in my feed app posts. And we can go ahead and create a new post. This is my first post. Save. Now, if you look at this, this says post object. In Django, every time we access a piece of data or a row in our database, it's called an object. And so we want to change this object name because it always just says the name of the model, object 1, object 2, object 3. We don't know how to identify that. Let's go ahead and make it identifiable. So in our models.py here, we can say def __ string. This is a class, so it always takes self as its first parameter. And then we're going to say return self.text. And whatever this post is going to be, that's what this object is now going to be called. So Django's restarted. Let's refresh this page, and we're going to see this shows up with my actual text in here. So we've given this object a name, and this is just good for the admin when you're sort of debugging stuff or adding content through your admin. We can click it, we can change it, updated, save and continue editing. We could delete it if we wanted to. Let's go ahead. Yes, I'm sure, delete this post. Let's go add another one. This is a new post. Save. Now, here's the thing. A lot of people think that just because we created this object, that it should show up on our page. And that's simply not true. All we did was create a piece of data in our database, or we provisioned a table in our database. We added a row into that table. So think of it like a spreadsheet. We have this giant spreadsheet, and that's our new table. And then we have 2 columns in there, in our little metaphorical spreadsheet here. We have two columns. We have one called ID and one called text. This one is an integer field, and this one is a text field or a char field, a character field. So it can't have 10,000 characters, but it can have 140 characters. And we call that a char field or a character field. But where people get a little bit confused is it doesn't show up on here. And that's because it simply doesn't know how we want it to show up. How do we want to style our website? Where do we want to place this stuff? No framework in the world can tell you that. It's not going to know automatically. You need to tell it explicitly what to do. So in our next lesson, let's go ahead and add our first view and update this a little bit. All right, we need to add our first view, and this is a little bit involved, and once we set it up, it's really nice to use, but to begin with, it can be a little bit tricky. So our site comes with this file, not this one, that's the wrong one, urls.py. We can read through this. I would definitely recommend reading through that. I'm not going to read through that for you, just because that's honestly a waste of your time. And then we have these things called URL patterns. And URL patterns is going to match some sort of path to some sort of logic. And for us, that results in localhost port 8000/admin. Now we can change that admin if we wanted to by changing it to myadmin or literally anything else we want. I'm going to keep it as admin just for the sake of keeping things simple. But now let's say we want to add a new homepage. We need to overwrite the one that Django gave us. And Django gave us this one right here. We don't want this anymore. It's nice, don't get me wrong, but we want to see something else. We want to make this our own application. Now our application is going to look really ugly, and then we're going to make it look really nice. So we're going to work on the back end first, and then we're going to add the front end later. So we need to add some URLs in here. Now, it doesn't really matter where we start. We need to do a bunch of things sort of at the same time. So what I'm going to do is in this folder here, I'm going to create a new file called urls.py, and that's just going to live beside my models.py and my admin.py. Now in here, we're going to be doing a few different things. So first of all, let's go ahead and say from django.urls import a path. And we saw this in the previous file, Django URLs import path. We want to use something like this. Now we're going to create our own URL patterns, and this is simply a list of paths. Let's go ahead and also give this an app name, and this is going to be used for namespacing. We'll talk about namespacing a little bit later, but for now, let's just go with it. We're going to give this an app name called feed. Then we're going to give it URL patterns is equal to a list. And this is going to take a path, and we just want the home page, so we're going to give it an empty path. And this is going to make sense in just a second. Then it needs to render some view, and that's going to be our template, and we give it a name. Let's call this index, or like our home page or something like that. Now, when it comes to rendering some view, we need a view to render. We're going to be using class-based views in this course because that's the proper way to write Django, at least in my opinion it is. We can write function-based views, or we can write class-based views. I'm going to teach you the professional way in this course. We're going to use class-based views. Function-based views are easy to learn, but it's easier to learn class-based and then functions rather than functions and then class-based. So this needs to come from somewhere, and we need to create some sort of view. So let's not save this yet, but let's keep this open and let's head on over to views. And you can see that it's already importing Django shortcuts render. We can honestly just ditch that because we're not going to be using a function-based view. We're going to use a class-based view. So we're going to go to, or not go to, but import from Django.views.generic import a simple template view. And then we're going to create a homepage view. So we're going to say class homepage view, and this is going to inherit the template view. And we're going to give it a template name. Template underscore name is equal to home.html. And this is telling Django, look for a file called home.html. And that's all we're going to do. So we're going to save that file now. Let's head back on over to urls.py. And if we do from, because this is in the same folder here, all of these are in the same folder, we can type dot views import And what was that view called? Home page view. And then we can say in here, homepage view dot as view. And this is going to render our logic for us. It's going to make our view actually work. Now, this is all well and good, but you've probably noticed that Django hasn't really been restarting lately. So let's go ahead and open up our mysiteurls.py and add a new URL pattern in here. Now, in here, we can prefix our homepage if we wanted to, so we can make everything go to mywebsite.com/home/ then a page, just like we did with the admin. But we don't want that. We want this to be the homepage. So we're going to leave this path blank. Then we're going to say include, and we'll worry about these imports in just a second. Feeds URLs, and let's give this a namespace of feed. Now, feeds URLs and include don't exist yet, not in this file at least. So we have to make them exist. So let's do from django.conf.urls import include. And let's also import our views. Not our views, but our URL patterns from our feed. Let's do from feed import URLs as feed URLs. And so we're just changing the name. We're importing URLs as an entire module. So we're importing this entire file here. Then we're renaming it to feeds URLs or feed URLs. And then we're going to simply put that in here. Let's go ahead and save this and watch Django restart. And we're going to see I have a typo somewhere. In feed URLs on line 1, it is not django.url, it's django.urls. And let's go back to where it says an error here. And this is nice. This is just, we're debugging at this point. And this says, path feed URLs is not defined. And that's because we said feeds URLs. Feed is singular. Okay, cool. That's all working. Let's head on over back to our browser and let's refresh. And we get this error. Template does not exist. Now, where do we put this template? Django is going to look for this template in a few places by default. It's looking in my pipenv here, and then it's going to look in Django contrib admin templates home, Django contrib auth templates home. We don't have access to those. Those aren't folders that are in our project. So we need to tell Django to use templates somewhere else. And we're going to create, in the next lesson, we're going to create a folder called templates, and we're going to tell Django to register it as a place to look for our templates. So for now, you should have all these URLs. This does get a little bit tricky because we're using URL patterns in my site. We're also using URL patterns in the URLs file under our feed app. They're both called urls.py. This is a naming convention. This is where it gets a little bit tricky, is frameworks like their naming conventions. We have an app named feed. It matches our app up here. That is also being used in our namespace. So it's all the same right across the board. We'll talk about namespacing in our template a little bit later. Then in our views, we simply created a homepage view, and that overwrote that nice Django view to give us an error. And once you see that error, you're ready to move on to the next lesson. All right, in the last lesson, we got this error. This template does not exist at / and is looking for home.html. Now, we know that it's looking in places that we don't have access to. And so we can go into this folder, users, caleb.tallene.local, share, virtualenv, Django 101, yada, 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 /Django, contrib, auth, templates home. That is just a nightmare to deal with. And there's a better way to live your life. And so in this lesson, that's what we're going to do. We are going to tell Django, hey, there is a better place to look for templates. So what we need to do here is we need to go into VS Code. Let's close that down. That's not relevant in this lesson. Let's close up feed and let's go into our settings.py. And in our settings.py, we have this thing called templates. If we scroll on down, we'll see them templates. And it's looking for directories. And so what we want to do here is create a template directory. So I'm going to give this a variable called template dir, and this doesn't exist yet. We have to make it exist. Template dir is equal to, and at this point in time, if you don't remember this, if you're setting up a project, let's say a year from now, you can always just Google this. This part is all over the internet. It's easy to find this particular way of enabling certain template directories. So we do os.path .join our base dir, and we're going to give it a folder called templates, and that's supposed to be base dir. And let's see if we can find base dir. Where are you? There it is at the very top here. And so that's looking for the path of this particular file. It's resolving it, parent, so it's moving up. And that's going to give us our project base. That's right in here. And then it's going to create a new template, or a new directory called templates. Now we used OS, and so we need to import OS. So we say import OS at the top of this file. Let's go ahead and see what Django is complaining about now. So we're getting the same error, but you notice it says that it can't find, because it's using a loader, it can't find it in templates home.html. Let's go ahead and add that in. All we have to do now is create a new folder called templates. And in here, we can create a new file called home.html. Let's just leave this blank. Nope, I lied. Let's say hello world, and let's make this an H1. So it's going to be HTML enabled. And let's refresh our page. And it says hello world. If this does not work for you and you've done everything correctly, kick Django. Just cancel Django and restart it. Sometimes, and not often, but sometimes you need to manually restart Django when you're developing using Django. And so now we have something in here. We have something we can work with. But let's go ahead and right click and view our page source. The only thing it says in here is hello world. And it's got an H1 and a closing H1 tag, and that's fine. But what if we wanted to have a title on our page? Currently, there's no title. Or what if we wanted to say that the language was English, or that this page was supposed to be responsive by default? Well, currently what we have to do is HTML:5, hit tab, and it builds this page out for us. And then we could say, hello world, save, refresh our source, and we get all this stuff. But what happens if we have another view? Then we have to copy all this. We have to copy all of that stuff, overwrite the title, overwrite the body, keep everything else the same. And what if we wanted to add a new meta tag to all of our pages in the future? Well, we may or may not want to write that over and over and over again. Now, if your site is huge, and let's say you have like maybe 100 different views, you're gonna have to copy and paste that 100 different times in 100 different templates. That's painful. That's no way to live your life. There's a better way. And a better way is to use this thing called a base template. So let's go ahead and just undo this. And actually, I'm going to delete that entirely. And I'm going to create a new file in here in the templates directory. And I'm going to call it base.html. And in here, I'm going to give it HTML:5, image sharer, stuff in here. And when we go back to our page, we see nothing. That's proper. We don't want it to do anything. It's trying to render this home.html, not base.html. Because if we look at feed views, we're saying, look at the template called home.html. Currently, it doesn't know about base.html. It's in our project, but Django is not aware of it yet. And so what we can do now is write extends base.html. And that has to be a string. And so we use a curly brace, %, the keyword extends, and then in here, a string called base.html that matches the name of our base.html file here. And then %, curly brace, and that closes that logic. Let's go ahead and refresh, and it says stuff in here. And if I go back to the source, it's all in here. Now, that's cool and all, but if we actually wanted to change anything in home, let's say, this is my new home page, this simply is not going to show up. It just doesn't. It doesn't know what to do with it. And so in the next lesson, we're going to talk about blocks and how we can basically write a little bit of code in our base.html file and simply inject stuff into it. And so you can think of it as like you have a piece of paper and you have a hole cut in it and it's just a circle. And then you have another piece of paper, but it's cut in the shape of a circle. And so you put that one piece of paper into another piece of paper. Like when we were kids and we were playing with blocks and we're trying to fit the square in the square and we're trying to fit the triangle in the triangle. That's exactly what this does. We're going to learn about that in the next lesson. All right, in the last lesson, we talked about sort of fitting shapes into shapes and and, trying to replace this stuff in here. We have a base.html file, and home is then extending from base.html, but it's not actually doing anything other than pulling in all this stuff, and we want to be able to replace some of it. So let's talk about this notion of blocks. And so a block looks like this. It's a curly brace, %, block, and then a name, and we're going to give this a name of body. Sometimes you see the name body, sometimes you see the name content. It doesn't really matter what you name it, as long as it's consistent across your application. And then we say end block. And that's all we're going to do in our base.html. Let's close views, let's close settings, we don't need those. And in our home.html, we do the same thing. Block, body, stuff in here from home.html, end block. And look at that interesting syntax. Django templates use two forms of syntax. They use a curly brace and a %, and this basically says execute some more advanced logic. Or if we really just want to print stuff, we use what I call a double mustache. So we use two curly braces side by side and then close them with the opposite curly braces. We'll talk about those in a little bit. But for the time being, let's refresh our page and we see it says stuff in here from home.html. Let's refresh our source code and it has all of this stuff in it now, plus our content from home.html. Now, what's nice about that is in our home.html, in our homepage, we don't have to write all this junk. All we need to do is say, hey, Django, when you render this template, grab base.html, read it for us, and then Django says, okay, yeah, I got that, I got you. I'm reading base.html, but hey, by the way, there's a block in here called body. And so if you want to, I could put some extra stuff in there for you. And we say, cool. Yeah, we actually do. We have some extra stuff. We want to replace your empty body block with some of our own stuff. And that is literally all we did. This is our home page. And when I refresh, it says this is our home page in our source code. Come back here, and this is our home page. So now we are actually working with a couple different templates. The nice thing about this is we can change one thing in our base.html. And if we simply say extends base.html from our home or any other template in the future, every template will inherit that code. So we no longer need to worry about writing the same head stuff every single time, or the same HTML declaration, or the HTML tag. We don't have to worry about any of that. We can just do it once. Now, as another example, let's go ahead and let's write a block in here. Block title, end block. And we're going to see that our title goes away. There's not going to be anything in there, just as localhost port 8000. And in our home, let's do block title, homepage, end block. And let's actually call it something way better. My super awesome homepage. Refresh, and it says my super awesome homepage. And again, all that did was say, hey, there's a block title here. We're extending from base.html. There's a block title here. All we really did was say, hey, grab this code, and it's like copying and pasting it in here. It's like that. Now I'm just going to undo that. And one more thing we can do is we can give default content in here. So default title. In case I ever forget to add the block title in a template, let's say, whoops, Caleb forgot to add that in there. Let's refresh our page, and it says default title. So if we don't overwrite it, we now have a base in here, a default. If we do overwrite it, it's then going to use whatever we used instead. So let's save that, refresh, and it says my super awesome homepage. And that is how we use blocks. That is literally all there is to a block. It is simply like that metaphor I made in the last lesson. When we were kids and we had those little toys and it was like, here's a circle fitted into the circle, or here's a square or a cube fitted into the shape that looks like a square or a triangle. That's literally all this is. This is our cube. This is our square. We're just fitting one shape into another. All right, let's talk about adding some custom context to our page, because right now our homepage is cool, but honestly, it's hard-coded. There are no variables whatsoever. There's no way to add any custom logic to this thing. And so at this point in time, we really just have a really fancy static website. It's using Python, it's using Django, but it's static. There's no dynamic content to it. So let's go ahead and talk about this thing called context. So let's close our base.html because we don't need that anymore. And let's open up our views.py. And in our homepage view, we can have a method in here called getContextData. It's a method on a class, so it always takes self as its first parameter. And then it takes keyword args. And then basically we're working with this thing called context. And so what context is we can add data in here from Python, custom Python logic, and then we can throw that into our quote unquote context and use it inside of our page. So we're going to quickly whip through a little example here, and then I'm going to show you exactly how I found out that getContextData even exists. How does this exist? How do I know that this exists? I'm going to show you how I found that out. So I'm going to do context is equal to super, and that's going to go up to the template view, .get context data, and we never pass in self, but we can pass in our keyword args, our kwargs, and we simply return context. In here, this is basically a dictionary. We could say my thing is equal to hello world, smiley face with a tongue hanging out, help world, hello world. This is dynamic. Django restarts, and what I can do here is I can take this, my thing, go over to home.html, and instead of writing this is our home page, because this is simply a variable, we don't want to do any extra logic with it. We're not writing a for loop. We're not telling Django to fit a shape in a shape using a block. We're not doing any of that. We simply just want to print something out to the page. We use the what I call double mustache syntax. So a curly brace, then some stuff, and then an ending curly brace, curly brace. Now inside of here, we simply say my thing. And that my thing is coming from right here, my thing. Let's go ahead and refresh our page. And it says, hello world, this is dynamic. Now, in our template, it doesn't say that, but in our view, it does. So now we can have some form of logic, and this is starting to get a little more dynamic. Now, this is still not a great example, and we'll work with this to make it a better example in the future. But right now, this is a decent enough example of how we can basically perform some Python logic, put it into a string or a number or anything we really want, and then access it in the template. Now, I mentioned I was going to show you where I got getContextData from. And there are a few amazing Django sites out there. One of them is called CCBV, Classy Class-Based Views. And so it's ccbv.co.uk. It's got different Django versions in here. We're using Django 3, so it's automatically selected. And I'm using a template view. And where I get that from is this template view. And all it's doing is rendering a template. It's not doing anything extra. There's a lot of different views in here. There's a login view, logout view, detail view, all sorts of stuff. We're going to be working with a few of these in Django 101, but right now we're only working with our template view. So I click on template view, and it tells me what kind of content type it can be, extra content, HTTP method names. So is this allowed to have a get, a post, put, patch, delete, head options, or trace HTTP headers? Honestly, we're only using get, so you could set this to just get. A response class, template engine, and a template name. Currently, we're only using the template name because everything else is automatically done for us or handled for us. And what I like to call it, because it's sort of magic, is auto-magically handled for us. And then we have these methods, and we have asView, which we've actually used, believe it or not, in our urls.py, homepage.asView. And we could see what asView is doing. And it's doing all of this stuff automatically for us, so we don't have to write that. Dispatch is like our init method, almost. It runs basically right after init. More or less, that's true. And we have one in here called getContextData. And I just happen to know that context is what we call it. And that's because I've read through the Django docs a few times, and so I'm sort of familiar with that notion. If you haven't read through the Django docs, definitely spend a little bit of time and read through the Django docs whenever you have an extra 5 or 10 minutes. There's a lot of docs, so it's going to take you a long time. It's not something you can read in an hour. And the docs are pretty well written. So get context data is doing this. It takes self and keyword args, which is get context data, self, keyword args. It's going to do kwargs that set default view is equal to the self. If self.extra content is not none, do some other stuff. Otherwise, return the keyword args. And we basically said, yep, cool. Whatever Django's doing, let's do the same thing. So we grabbed our context by using super.getContextData, passed in those same kwargs that are being passed into us, added a little bit of context, and returned the entire thing. So in the future, when you're learning, a little more advanced Django, you can always go to ccbv and just waiting for this to load. There's all sorts of stuff in here. So feel free to take a little browse through this. But for the most part, we're just going to stick with something basic for now as to not overwhelm you. In future lessons, you might even see me reference ccbv, just because honestly, it is a great resource to have, and it tells us things like when we're using getContextData, does it accept a request? Does it accept args? Does it accept only self and kwargs? What does it accept? We don't know, and we might need to know that when we use super. And so this is a really good reference for that. In the next lesson, let's go ahead and display our posts on our home page. Okay, in the last lesson, we talked about getContextData, and we added this thing called myThing, and it's simply a string. MyThing is a string, it rhymes, and I didn't mean that to rhyme. No more rhyming, and I mean it! Would anybody like a peanut? Little movie reference there if you're a movie buff, from The Princess Bride. And so we're going to go ahead and swap out myThing for posts. And what we want to do is we want to get our models. We have these posts, and we did this in like the first couple of lessons. Woo, that got way too big. We have these posts in here. So I've got this one post in here. Let's just go ahead, save that, add another post. This is a second post. Save, add a post. This is a third post. Save. And now let's actually make these show up on our page, because right now, nothing shows up. And so what we want to do is we want to grab these posts and get all of them. And so what we can say here is context post is equal to post, and I'm getting that name from this class. We haven't imported it yet, we will in just a second, but this class name, dot objects, because surprise, surprise, basically everything in Python is an object. And in Django, they're still objects. It's written in Python, so everything's an object. Dot all. And that's going to get all of our posts for us. Then we can say from dot models import post. And that's simply going to allow us to grab this post, pull it into our views.py, and then when this page is rendered, it's going to say execute getContextData, do whatever Django does. There's a variable in here called posts, and it's going to be all of the posts. And so let's go and swap out myThing for posts in the template. And we are simply going to, for now, for the time being, use double mustache syntax. Let's go ahead and refresh this. And we see this weird thing, this thing called a query set. And so in a database, when you are looking for data, it is called a query. And we have a set of a query here. So we've got our first post, and this is a new post, second post, and a third post. And this is somewhat of a list. This is a really, really fancy Django list. And so we can loop through these now. And so instead of writing posts, what we can do is, let's get rid of this H1. We don't need that in there. We can say for post in posts, and for. Show me a thing. Let's put a horizontal rule in here. And this should show 3 times, show me a thing, show me a thing, show me a thing. Now this is, let me fix that indenting because that's going to drive me nuts. This is looping for every post. And we know that when we loop through every single piece of data in a list, we have that exact item. And this is just like looping through a list in Python. The only difference is this list comes with extra stuff. So it's like looping through a list of dictionaries. And so now we have post and text. And so we can do post.text in our template. And so let's go ahead and write post.text. Refresh our page and it says, let me zoom in here. This is a new post. This is a second post. This is a third post. Let's go ahead and add one more in here. Let's make that smaller again. And this is a fourth post. Save. And when we refresh, boom. Now we have data being put into a database and data being pulled out of a database and rendering in a template. This is literally all we need to do for this particular lesson. In the next lesson, let's go ahead and add some images here. All right, let's talk about how we can add an image. And so we can do a few different things, but we're going to sort of bypass some of the intricacies, and we're going to work exactly in our models.py. And so Django gives us this thing called a models.file field. And we can upload any form of file, but that's not quite what we want, because maybe we want to have some thumbnailing and stuff as well. So what we're going to do now is install a new package, and we're going to use that package. So I'm going to reference the docs right in front of you, and I'm going to show you exactly how I do it. So I'm going to delete that, go back to my browser, and type in Django thumbnail package. Django thumbnail, that's not what I typed. Package. And there's Django thumbnails, there's Sorrel thumbnail. I've used Sorrel thumbnail once or twice before. Apparently I've clicked this. So let's take a look at our docs here. Features at a glance, supports Django 3.1. That's what we're using, that's important. Python 3 support, very important. Storage support, that's good. Plugin engine supports Pillow, ImageMagick, Pill, Wand, all sorts of things. These are all good things. If you don't know what those are, that's okay. Admin integration with possibility to delete, dummy generation, all sorts of stuff. Do we have thumbnailing and cropping? Alternative resolution versions of a thumbnail. Margin calculation for vertical positioning. This looks promising to me. And so, how to use the code. Pip install Sorrel thumbnail. So let's grab that. And in our virtual environment, I'm simply going to paste pip install Sorrel thumbnail. And if you're using pipenv like I am, we should be using pipenv install Sorrel thumbnail. Either way, we can still do pip show Sorrel thumbnail. And that shows us that we're using version 12.7.0. What else do we have to do? We need to put Sorrel thumbnail in our installed apps. Let's do this. Where are we here? My site, settings, installed apps. We're going to scroll down. Let's just throw that somewhere in the middle, like that. And then there's some usage in here, but we need to actually add it to our model. Here it is, model usage. We want to follow this. So let's go back to our models.py, and what do we see here? From Sorrel thumbnail import image field. From sorrel.thumbnail import image field. And in here we could say image is then equal to that image field. And so now we're using a third-party package that layers on top of Django, which layers on top of Python, to basically create an image field so we can upload images and then thumbnail them nicely in our template. Django doesn't come with this by default, just because Django is quite bare bones. It gives you the bare minimum and lets you extend to do whatever you want it to do. It's not meant to have every solution built into it. It's not designed that way. And the reason for that is because if you were to create a website that didn't need Sorrel thumbnail, and it came with Sorrel thumbnail, well, that's just loading extra stuff. That's extra stuff to download. It's just not worth it. And so Django says, other people can build these extensions. So we added this image field in here. Let's go ahead and run server, and it says, look at this. Feed, that's our app. Post, that's our class. Image, that's our field. Cannot use image field because pillow is not installed. Hint, get pillow at or run python-m pip install pillow. So let's do that. Pip install pillow with a capital P. Okay, that's done. Let's run Django again. We have one unapplied migration. Let's do python manage.py migrate. And this is applying our thumbnail initial. Cool, that's from our third-party package, so it's provisioning a little thing in our database. Let's see if we can make our new migrations, because we need to make new migrations. So these migrations that we just ran came from Sorrel thumbnail. When we make migrations here, what we're saying is, Django, hey, take a snapshot of what we currently have versus what we used to have, and if there's any changes in there, create a migration file. And so we said this post class now has an image field on it. And so let's go ahead and run make migrations. And this is going to say that the image field is not allowed to be null. We can either press 1 to provide a one-off default, or we can hit 2 and let's set a default in models.py. That's right, in here we could say something like default is equal to something. We don't know what that default is though. So let's go ahead and say 1 and see what happens. And I'm just going to type 1. And maybe this breaks, maybe this doesn't. If it breaks, I'll show you how to fix it. And I'm just going to type the number 1 in here. So it created a new migration file called 0002 post image. And so if we click this, it has a dependency on the original migration file. So it needs that file. And then it's going to say, for the operations, things that should do, add a field, and that field is coming from sorrel.thumbnailfields.image field. It's a default of 1, that's what we wrote to. Upload to, we didn't give it an upload to, that's just like a folder we could upload to if we wanted to. Preserve default, false. And so basically this is going to give us a new column in our database. Let's go ahead and now run migrate. And so originally when we made our migrations, we simply made this file. We didn't execute it. Then we run migrate and that says, hey Python, by the way, I want you to take this file and I want you to apply it to my database. So let's go ahead and rerun Django and see what things look like in there. Things so far look good. Let's head on over back to our browser. Oh, let's see if we actually broke anything. Okay, that looks okay. Fourth post. Currently set to 1. That's not at all what we want, but we could change that. What I'm going to do here is I'm simply going to delete all of these because I want to add new images. So I'm going to select all of them. Delete selected post, go. It's going to say, are you sure? Yes, I'm sure. Add a new post. This is the first post, and let's add an image. And let's add an image of gully2.jpg. Open, save. And now there's a file in here, and we can actually even click that. And it says, oh no, this actually doesn't exist. And beyond that, if we look in here, let's close up all those files. Our image is in here. So let's say you had 10,000 images. You now have a folder called feed, a folder called my site, a folder called templates, your database, 10,000 images, manage.py, pipfile.lock. That's no way to live your life. We want to put all of our files, our media files, that's what we call them, all of our media files into a folder called media. And that's what we're going to do in the next lesson. So right now we have an image field set up. It's not displaying anything on our homepage yet. We need to set up our media folder so that all of our images get uploaded to one particular folder. And this is really nice. If you ever needed to zip up all of your folders, or all of your images rather, you could zip them all up quite easily. You could delete them all quite easily. You can work with them easier if they are in a folder. So the next lesson, let's go ahead and set up our media folder. All right, let's take a look at adding a media folder to our project so that all of our images don't get uploaded straight to the root of our project. In order to do that, we have to open up my site, settings.py, and pretty much anywhere, I guess. Let's just throw it in here. We can write media URL, and this is just going to be the name of our folder. And it's going to be /media with a slash at the end and at the beginning. Then we're going to write our media root. Media root is going to be os.path.join base dir, and then we type media without a slash at the beginning. And so this part here looks pretty familiar, doesn't it? We set that up with our template directory, but instead of using the templates folder, we're using the media folder. And our media URL is going to be when you're accessing content when you go to mywebsite.com/something, what is that folder called, wherever that folder is, and then your image.jpg or whatever. So we need this setting. Even though we're not currently using it, we need that setting. Then let's go over to our urls.py. And we need to write some interesting stuff in here. So we're going to modify this a little bit. So first things first, we're going to need our settings. So let's first of all move this up so it's in alphabetical order, just as a good practice. From django.conf, import settings. And then let's also import this, this function called static. From django.conf.urls.static, import static. Not status, it's static. Then at the very bottom, we say if settings.debug. And what debug means is, you know when we didn't have a template and it said there was a template error and it showed us where it was looking for that particular template? That's what debug does. Debug allows us to easily figure out what's going on. And in production, when you launch your website, we actually turn this off so that people can't see all of that extra information, because that will make your site vulnerable. But while we're coding it, we want it enabled, and it is enabled by default. Then we say our URL patterns. Let's add to this URL pattern. We're going to say static settings.media URL, and then the document underscore root is equal to settings.media root. And so this is just using a pretty standard, well, it's Python language really. We're importing settings, the whole file, and then we're using the property in that file. We're just importing settings. Again, it's basically an object. And then we're using the media root, and we got that from our settings in here. Media URL, media root. Let's go ahead and save that and see what happens. Okay, looks like nothing happened, but let's go and refresh this page and then change this image. Instead of Gully 2, let's put Gully Belly. Save that. And let's view it. And you can actually see /media gullybelly.jpg. And let's take a look in our project here. We now have a folder called media and Gully Belly is in there. That's fantastic. We can now get rid of Gully 2 because that was our original one. Let's delete that. We don't need that anymore. And all of our folders, or not our folders, but all of our files are going to be uploaded to this media folder. So as a quick recap, what we did was we added media URL and media root. And this is a lot like when we created our template path. This one, our template dir. This one is our media root. And then we used a media URL and that media root in our URL patterns. And so the idea here is that when you serve static files with debug turned on, Django is going to serve those files for you. That's technically an insecure way of using Django. So when you launch your website at some point in the future, you don't want to be using that, and you're going to have debug turned off and your static files are going to break. Then you can use something like Nginx to reverse proxy the images and set it up that way. We're not going to talk about that for right now, just because that gets to be a little bit more complicated and a little too overwhelming when you're just learning Django. But for now, this is what we need to get up and running. Just that. In our next lesson, let's go ahead and actually add this image to our home template. Okie dokie, let's add images to our home template, because if we take a preview, and we can close that, if we take a preview of our page, it simply says this is the first post, but there's no image in here. Let's go ahead and add an image in here. And so we have to open up our templates, home, and we know there's post.txt, and where I'm getting that from is models.py post.text. We now have an image. We can do post.image. So let's just print that out and see what that gives us. Let's do a BR in here, post.image. Let's see what this returns for us. The name of the image. I could probably do post.image.url. Yep, there it is. That's the actual URL. And if I were to wrap this in an image, img src is equal to, we're going to see that this is a giant, giant, giant image. We need a thumbnail because this image is just so big. So big. Look at that cute face. And we want a smaller image because this image I know is already over 3 megs. And if we were to show like 100 images, someone has to download 300 megabytes to view your web page. That is simply unacceptable. So what we can do is now reference our Sorrel thumbnail docs. And how do we do this? It says template usage. We want to load a thumbnail. So let's go back to our home page and put load under extends. Extend should always come first, and then we load. And then what do we write? We say a simple usage. Okay, I'm just going to copy and paste this, to be honest. And so this is going to use a thumbnail that comes from up here. Item.image. We don't have item. We have post.image. 100 by 100. Let's do 200 by 200. Crop center as IM. And then we could say the image source is im.url, width is im.width, height is im.height. Let's go ahead and save that. And let's go back here, simply refresh, and it created a thumbnail for us. Cool, so that's a perfectly centered 200 by 200 image. Let's go ahead and inspect this. And it created this weird URL for us. Let's open this up in a new tab. And this is the image. It's in our media folder. It automatically created a cache folder called bbc1 and then some sort of hash. And that's just simply using caching for us. So it doesn't have to regenerate that thumbnail every single time someone hits your website. So that's really nice. And that first time we loaded the website, you notice it probably took like half a second slower rather. When we refresh this time, it's going to be pretty much instant. We don't see a flash or anything. It's just, boom, it's done loading. Let's go ahead and add a second post. So let's save that one. This is a second post. Let's add an image. Let's add rhubarb. Save. And let's refresh our page. Let's get rid of our console here. Let's refresh our page. Oh, look, there's rhubarb. Let's go ahead and add one more. This is a third post. And let's add a photo of rhubarb and gully. This one's a big one. This was 4.2 megs. Thank goodness we are thumbnailing. And there it is. This is all up and running for us. In the next lesson, what I would like us to do is be able to click one of these images and go to another URL somewhere and see the full image. Okay, what I would like us to do is be able to click either this text or the image or both, and then go and see a different web page where we show the full image, the uncompressed version. And to do this, we use this thing called a detail view. And so it's right in the name there. It's a detail view. We need to add a new view. So let's go into our feed, go into views, and let's add a new detail view. And this comes from generic detail view. And if you aren't sure where I got detail view from, or you aren't sure where to import this from, because you don't have to remember all the imports. It just comes with, writing Django and Python over time, you start to remember them. But if you don't know where it comes from, you can always go to ccbv.co.uk, and that will tell you exactly where it's coming from. In fact, I'll show you where it's coming from. We have a detail view. Where are you? Generic detail view. And it says right up here, from django.views.generic import detail view. And we can do all sorts of stuff in here. And so it has a content type, content object name, extra context if we wanted to add extra context, HTTP methods, a model, we need to set that model, primary key URL keyword, yada, 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 all sorts of stuff. We're not going to work with a lot of this. We're just going to work with some of this. So we need to create a new detail view. So let's do class, and let's call it post detail view. And this is going to inherit from Django's detail view. Then we give it a template name, and that template name simply is going to be detail.html. And that model is going to be post. And that post is coming from up here, which comes from our model here. And really all we're saying at this point is saying, we have this model, we have this detail view. If you go to a particular URL, just auto-magically work for us. Just fetch that particular image for us, that particular post. And so we don't have to do a lookup. We don't have to worry about managing our database. Django manages this detail view for us. And all we have to do is write 2 lines of code. It is honestly a beautiful, beautiful thing. So I save that, Django restarts, nothing happens. What we need to do now is go into our URLs, our feed URLs, and we need to add another path in here. So we can type path, let's say details slash some sort of integer. That's going to be the post ID, and render a view. And the name is going to be, let's just call it detail. And this should be more like that. So let's not do details, let's do detail. And instead of int, because that's just going to render mywebsite.com/detail/int, we want to say int::pk. So it's looking for an integer. And when it renders our view in here, it's going to be renaming that integer, whatever that is. So it could be like website.com/detail/1. It's going to look at that integer and it's going to name it pk. Then we need to render a view. And that view is called post detail view. So if I go back to URLs and let's do from.views import homepage view, let's also import the post detail view. And that's a class, so we use as view. Okay, Django's not complaining so far. So far so good. Let's go ahead and try this out just to see where we're at. So first of all, we need an ID. If I click this, it says the ID up here, post is 8. So let's go take a look at post 8. So we can now do our website, localhost port 8000/detail/8. And something in here is wrong. Oh, and that's because I put a slash at the end here, and there should be a slash right there. So just wait for Django to restart, refresh, and we should get a template not found error. There it is. The template does not exist error. It's looking for detail.html. Now, where is this looking? Well, it's going to look in our templates folder called detail.html. Templates folder is called templates. The file is called detail.html. Or it's going to look in this package, or it's going to look in this package. So let's just give it the first place it's looking. Templates, detail.html. So we go into our templates, new file, detail.html. And let's just write hello world. Let's do nothing fancy here. Hello world with a heart. Oh, that's not going to work. It's HTML with a smiley. Cool. Okay, we have a view being rendered here. This is good news. Let's go ahead and extend base because if I back up real quick, let's view the source. There's nothing in there. Let's go ahead and extends base.html. Let's refresh a page. It looks like nothing happened, but if I view page source again, we have stuff in here with a default title. So let's do block title, detail view, and block. And it changed the title up there. That's good. That means this is working. Block, body, and block. This is where my image will go. This is where my image is going to go. So what I'm going to do is I'm going to stop here, and in the next lesson, we're actually going to fill out some of the details on this page. We're not going to make it look great, but we're going to fill out some of the details on this page. All right, welcome back. This is our detail page. This is supposed to show this image here, rhubarb and gully. Currently, it doesn't show anything. Nothing in here is dynamic. Now, we know we can use get context data, but we don't need to do that because Django manages a lot of that stuff for us. So if we open up our views.py, we're using a template name called detail.html, and we're saying that model is post. If we open up our urls.py, our path is detail and then some sort of number. And it's going to automatically figure out that there is an integer in there, reassign it to the variable called pk, and somewhere in this detail view, it's going to work that out for us. It's going to say, oh, I know exactly what you're looking for. Now, by default, if it can find what you're looking for in your context, what would we call this? Because before we were calling it like posts or my thing, we need to call this something. And so let's go ahead and try object. And it gives us the object. And in fact, actually what this is doing here, I'm really glad this came up, is it gave me the text. And that's because if we go to the models, it gave us the post object, but it gave us the string representation of this, which is just self.text. But presumably we could do object.text or object.image. So let's do object.image. Okay, that's the image name, so almost there. What if we did image.url? That's our URL, that's what we want. So let's go ahead and hash this out a little bit. So let's say h3 text object.text, and let's do h3 image, and this is simply going to be an image tag, img src. Let's make this a little bit responsive. We'll add Bootstrap later to this. Width 100%, height auto, and boom, there it is. Look at those cutie pies. And so now we have a detail view. In the next lesson, what I would like to do is, if we just click back, these aren't clickable yet. So we need to figure out how to make these clickable and where to go, because we can hard code this. We could, in our our home.html, make this a link that goes to /detail /post.id if we wanted to, because we know that ID column exists. There's a better way to live your life though. And what if we ever changed it from detail to details or image or some other prefix in our URL here? What if we wanted to change that? Well, then we'd have to change it in our home. And I'm going to show you a way that we don't have to do that. We can just basically say, hey, Django, handle this for us. And if it changes in the future, also change it here for us. So that's what's coming up in the next lesson. All right, let's take a look at making these clickable to another page. So first of all, let's close detail, views, and URLs and models. We just need to work with our home.html for this particular lesson. We need to create some sort of link. And so what we could do is href view details. And then in here we could say go to /details /post.id with a slash. And when I click this, oh, see, this is exactly why we don't do this. It's not details. I keep doing that. It's detail. Refresh, go to details. Okay, that works. And that works. What if, for some reason, I changed it from details to info? Okay, so I'm going to go back to my home page now. Refresh. My page is no longer going to work for me. And you can see it gives me a 404. So something broke. Now, there's a nicer way to do this. We gave this a name, and there's this namespace in here. And that namespace also matches, where are we? My site, URLs, that namespace matches here. So we can say, in our home.html, we can say, hey Django, execute the function called URL, then look for our feed, that's our namespace, and our detail view, and I'm getting that from namespace, that's our app name, detail view, that's our name, and then it takes an integer. And so as a string with quotations or apostrophes around it, and then outside of that string, I simply say post.id. And let's try this out. If I click this, it goes to detail /6. Let's go back to our URLs and let's change this to info. Refresh, wait for Django to restart. Refresh that. Click this again. And you can see my links changed. And the URL goes to info/6. And it automatically generates it for all of these images for us because it's in a for loop. So now, I'm just going to undo that because I like it being called detail. But now we don't have to worry about like hard coding URLs, which is really, really nice. Now let's go ahead and make this entire thing clickable. Let's do this. /a. And because this has some stuff in it, let's do style display inline block. And this whole thing is now going to be clickable. So now we could go and see Gully. Look at this cutie pie. Kind of chubby, kind of cute. Look at this cutie pie. And we can come back here. Now, what if we were making some sort of app, like almost like a mobile app, and we wanted a link up here that says go back? We could throw that on our detail page as well. So let's open up our detail.html, and in our body, let's add a link, ahref, go back, /a, and let's add an arrow, a left arrow. And in here, we can simply say curly brace, %, URL, feed, and I think we called it index. We're going to double check in just a sec. Feed also matches the namespace here, so we're using feed here. And then index. Now this doesn't have any sort of parameters in the URL, so we don't have to worry about passing in any parameters. Unlike when we use the post detail view, we said use feed : detail, and then we passed in a parameter. This one doesn't have a parameter. This is just the home page. There's no parameters to pass in. And so we use feed : index. Let's go ahead and refresh our page, and it says go back, and it's going to take us back to our home page. This is just going to keep working for us. Just keep working. And that's how we add URLs. In our next lesson, let's go ahead and add a form so that someone can upload an image on their own, and they don't have to have admin access. So anyone can visit your website and upload an image on their own. Okay, let's have a conversation around this idea of forms. So if you come from like a Node.js background, you may or may not use actual forms, but the proper way to use any sort of form where you upload data or you save something is to actually use form element. That is the proper way. That's the way we should all be doing it. New progressive web apps and single page applications often skip this entire process. We don't do that. And that also keeps our form nice and accessible. So if someone isn't running JavaScript or using an old browser, it's still going to work for them. So in my opinion, this is sort of the better way of doing it. You can always layer JavaScript on top of it to make your form really fancy too. But for now, let's just stick with a regular form. First things first, in our feed, let's go ahead and create a new file called forms.py. In here, we need to do from Django import forms. Now this is going to look a lot like from Django DB import models, class something models.model. Check this out. Class post form, that's what we're going to call it, forms.form. And that's pretty much all we have to do to create a form. Now we can give it some sort of parameter, or not parameter, but a field. What kind of stuff do we want to display in this form? And we do this with like text is equal to forms.charField. And unlike our models where we do models.charField, we do forms.charField. Let's also add an image in here. Image is equal to forms.fileField. We're going to upload a file. Whatever that is, we're just going to upload it. We're not going to worry too much about image validation or anything like that. We're just going to simply upload an image or upload a file and hope that it's an image, because this is Django 101 course. We're not getting into the nitty-gritty and complexities of Django. We just want something basic that works, that gives us a little bit of experience. So we have forms.py with a post form in here. Let's open up our urls.py and let's create a new path. And this is going to create a new page for us where someone can actually post an image. And let's call it post. And then it needs to render a view, and that name is going to be, let's just call it add. We're going to add an image. Or no, let's stick with post. We're going to post a new image. Now it needs to render a new view. Where are we going to get this from? Let's go create it. So first things first, let's just name it here. Add post view.as view. We're going to use a class-based view for this. And let's import that. Add post view, and when I hit save, you're going to see that Django has a little bit of a freak out. Yep, cannot import add post view, yada, yada, yada. We know it doesn't exist yet, Django. Thanks for letting us know. So let's go into our views and let's create a new one in here. Now, we want to import a form view. And what this is going to do is this allows us to post to our page, to actually upload things. So let's go ahead and create this new view. Class add post view. It's going to be a form view. Now, what comes in a form view? We don't know. So let's go back to CCBV. Let's go back to the home page. And where is our form view? right there, generic form view. And so this takes a template name as well. This takes a form class. Where are you? Form class. And a nice one, and I think it's always going to look for it, is a success URL. So when the form is successfully submitted, let's say there weren't any errors in it, let's say it was successfully submitted, where is it supposed to go? And there's also one method in here we really want to work with, and that is our form valid. If this form is valid, what is it going to do? It's going to give us an HTTP response redirect to the get success URL. Let's just follow this. Get success URL. If there is not a success URL, which we are going to set, but if there wasn't one, it's going to say improperly configured. Otherwise, it's going to return that success URL. So let's go set up our view first. We need to give it a template name, and let's call it newpost.html. We need a form class, and that's going to be something, we aren't sure yet, and a success URL, at least a success URL. And let's just make it go back to the home page. Now that form class, what is this going to be? This form class is going to be post form. And so we need to do from.forms import post form. Scroll back up to the top. From.forms import post form. And we can change this down here to post form as well. And look at that, Django isn't complaining anymore. If we go back here and go to, what was that URL? /post. Ta-da! Template does not exist. We've dealt with this twice now. We know how to deal with this. We simply need to make it exist. So what I'm going to do here is not base, detail. I'm just going to save this as newpost.html and just overwrite the content in here. Upload a new image is going to be the title, and the body is going to be nothing yet. It's just going to say empty. Boom, just like that. So now we're making views pretty quickly. Now we have to actually render this view somehow. We have not the view, but the form. We have to make this form actually show up. So let's get rid of base. Let's get rid of models. We have this add post view. What can we do? What does CCBV tell us? Let's go into get context data, form mixin, and if we read this right, if form not in quarks, then quarks form is equal to get form. So we know that this is in context. We can write form in our page. Let's go ahead and write form right in our template. Let's see what this does. Form. Hey, look at that. That's not bad at all. And there's a few different ways we can do. We can do form.asUL. And if we right click and inspect, it gives us, well, this is a table. AsUL, as P, better. As table, as UL. There we go, as UL. I don't know why it showed up as a table at first time. That was kind of bizarre. I think that might have just been old source code we were looking at. But as UL is going to create a list. And let's check this out. We now have a form. Now this isn't going to do anything if I go in here and hit enter. There is no form. And if we check out this source code, we just have LIs in here. And actually what I'm going to do is I'm going to use as P because I don't want to deal with lists yet. And so simply puts them on a new line. Cool. But we need to add an actual HTML form in here. So Django lets us control this by just giving us the insides of the form. We can write what we want on the outside of the form. So the form method is going to be post, and the action is going to be its own page. Then let's create a new div in here with a button, and the type is going to be not button, but it's going to be submit form /form. Let's check this out. Let's get rid of that page. Check this out. We have a submit, and let's try this out. And I'm going to show you that this is actually going to fail. First of all, it's looking for this thing called a CSRF token. And this is a cross-site request forgery token. And basically this makes sure that people are submitting the form from your website. And we add one of these very easily by doing curly brace %CSRF_token. And let's go ahead and try this again. Let's refresh the page, blah, 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 blah. An image in here. And we're going to see that this also fails. It says this field is required. Let's go ahead, add another image. It says this field is required again. What's going on here? We're adding that in there. Now here's the thing is when you upload images or files of any type on a form, you need this thing called an enc type. And we do multi-part / form data. And this allows us to actually send files from our browser to the server. So let's go ahead and save this, refresh. Oh, we don't want to do that. We want to do a hard refresh. This is a new photo. Let's go ahead and save this, or not save this, but let's get this image here. Okay, it sent me back to the home page. That was the request, or not the request, but that was the success URL that we wrote. That came from, where are we here? The success URL went straight back to our home. Now, if we go back to our admin here, let's check on our posts. Our post doesn't exist yet. We need to add a form valid post in here and create a new post with the data. So we have this method called def form valid. It takes self and form. Let's go back to CCBV and there's form valid right here. What is this going to do? This is going to return an HTTP response redirect to the success URL. So unlike our context data where we did context is equal to super and then a bunch of other stuff, we're not going to do that. We're going to do return super.formValid with the form in there. And let's make that lowercase. And then we can say in here, print, this was valid. And let's just like spam our terminal with this. And let's go ahead and go back to /post, new image. And again, this is not going to save yet. And there is an easier way to do this. We could use a model form if we wanted to. We're not going to do that just yet. We're gonna keep it simple with a regular form. So let's go ahead and submit this. And we're going to see that our terminal has a little bit of a spaz attack. It says this was valid over and over and over again. The form itself was valid. Now, if we want the data from the form, we can always do print form.cleaned data. That's the validated data. So if someone tried to write HTML or JavaScript or anything in there, it's going to clean it for us, which is really nice. Django just handles that for us. Text, we could just print that a few times. Let's go back to /post. We'll add a URL for this pretty soon. This is my text with a heart. And it looks like it did nothing, but it says this is my text with a heart. And so now what we can do, because this form is clean, we know that form.cleaned text with text as a dictionary key prints the text that was in the form. Presumably, the image is also going to work. So if we go back to forms, we have text is equal to forms.char field, and image is equal to forms.file field. Let's go ahead and create a new post. So we need to create a new post. Now, before we do that, we have to make sure post is in fact imported, which it is. And then we can say the new object, because everything's an object, is equal to post.objects.create. And if we take a look at our models, it's looking for text as a keyword and image as a keyword. So now we could say text is equal to forms.cleaned data text, and the image is equal to forms.cleaned data image. And then when it's done saving this, it's going to send us back to the home page. Let's go ahead and see if I made any mistakes in here. /post. This is my newest image. And let's do friends Lego set. And it says, ooh, name's form not defined. Okay, that, because, where are you? It's not forms, it's form. And the reason that it's form is because it's being passed in here as the word form, as the argument form. Let's go ahead and try that one more time. And a nice little thing we can do here is if you see something like this, you can just refresh your page. And it's going to say, hey, because this was a post method, do you want to try again? We're going to say yes, try again. Scroll on down. And this is my newest image. This is my Lego set that I made last weekend. A set of friends. Last but not least, we need to add a link to this actual view. Otherwise, people aren't going to know that this exists. So let's go to our home view and let's add a link. ahref is equal to, add a new post, and let's do a right arrow. And this is going to go to URL feed post. And where I'm getting that from is, again, feed, that's the app name, that's the namespace we're using, and the name post. So it's always namespace colon the name of the view. Let's refresh. Oh, that looks a little bit gnarly. Let's add an HR in here. Just a horizontal rule. There we go. Add new post. We can add a new post. Cool, 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 cool. Cool, 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 cool. And let's add Gully Belly again. Scroll on down and we see cool, 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 cool with Gully's belly in there. Okay, that's fantastic. This is actually working now. So as far as this lesson goes, this is complete. In the next lesson though, let's make the newest posts show up at the very top. All right, let's make the newest posts show up at the very top here. And so this is the oldest post, second oldest, third oldest. You can even see that they're named first, second, third. This is the newest image. Cool, 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 cool. That's the one we added in the last video. Let's reverse this. So let's go into our views here. Let's close all that stuff down. And let's just pretend we're starting from scratch. Feed. We need to go into our views. We need to see our homepage view. And we're basically looping through all of our posts, all of the available posts in our app. And so we're saying post.objects.all. That's going to get all of the objects. And then we can say .order _by, and we can order it by its text or some other form. And so we can order it by its text or order it by its text descending. Or we could order it by its ID, which is what it's doing by default, or its ID descending. And when I hit refresh up here, we're going to see that this order here flips. It's going to be completely reversed, just like that. And it just happened to be the first and last image are the exact same, but this was the newest one. This is the second newest one, third newest one, fourth newest one, and the oldest one. And so all we did there was we said, hey, Django, get all of the post objects, get all of them, and then order them by the ID. And we know it has an ID. Every model has an ID by default. And it's even in our migration here. It's called ID. Order by ID descending with a minus sign. If we set this, this is what it's doing by default, and it's going to order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we do descending, this is going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And that's all we need to do. Next up, let's take a look at how we can add some sort of message to our page when a new image is uploaded. Because when we upload a new image, it just brings us back to this page, and we don't actually know if anything has happened. I mean, I guess we could see this is a new image, and let's select the image of them cuddling. And it shows up at the top, so we can see it's working there. But what if you have a lot of users using this? You might not actually be able to see your image first. Someone might have submitted 1 millisecond after, and it's going to show that one first, and yours might get lost somewhere. We want to show a message. In the next lesson, we're going to talk about Django messages. Okay, let's talk about Django messages. So a message is basically a way to send a little bit of information from one page to another, but it only does it once. So if you're familiar with the idea of sessions, basically it creates a session, and once that session is accessed, it deletes it. And so we want to add a little message, a little session, and when someone fills out this form and it takes them back to this page, it should say, hey, you successfully added an image. And this is really, really easy to do. This comes baked in with Django 3 automatically. So let's open up our editor here, and let's open up feedviews.py. And first things first, let's go ahead and import. We want to do from django.contrib, I believe, contrib import messages. Now, if you're learning Django and you're working with an existing Django project, you have to go into your settings and make sure that messages is in there. So if we open up our settings and type in messages, Django contrib messages is in our installed apps. It's in our middleware, and it is also in our template context processors, which means it can be added to every single template. Doesn't matter what your template is, it can just be automagically added. And so you need to make sure you have those in there. So for now, we're going to do from django.contrib import messages, scroll on down to our form. And when that new object is created, let's add a new message. And so we can add a new message with message.addMessage. It takes a request by default. Let's do messages.success. There's different types. We'll take a look in just a moment at the docs. Your post was successful. And let's type in Django messages docs, the messages framework. And so it tells us that we need to have all this stuff set up in our middleware, installed apps, context processors, etc., etc. Storage backgrounds, message levels. Okay, so this is where I got messages.success. And is it messages? It's messages. That's what I imported. Messages.addMessage, messages.success. And this is where I got success from. So if it was successful, I'm going to give a success message. And this is going to be accessible in our template. If there was an info one, we could use messages.info, debug, warning, or error. So we have these 5 options. I'm going to go with success because I know that that is going to work well with Bootstrap, because Bootstrap usually has like, I think it's bg-success or text.-success, something like that. So I know that I think actually all of these might work except for debug, but I want the success color one down the road. And yeah, if we go down into message tags, it actually tells us. So success is going to give us the tag success, and that's going to be put into our HTML CSS attribute, our class attribute. And then how do we do this? It says adding a message. So we import our message. We did that already. Messages.addMessage. It takes request as its first parameter. A message type. Is it info, success, debug, error, etc. And then the message itself. And so here are a few different examples. And when we want to display messages, we can simply copy and paste this. Let's do this. For the time being, this is going to be fine. We can clean this up a little bit later. So let's save this. And let's go into templates, base.html. Let's close that database one. And because this is accessible on every single template, because it's in a context processor, which means it's accessible on every template, we can now say, if there are messages, create a list, an unordered list, and then loop through every message with an li. It says if there's message tags, add the tags in here. That's going to be the success or debug, or what were the other ones? Info, success, warning, error, and debug, and if, and then the message itself. So it's going to loop through all of them. We can have multiple messages. That's important to know, and that's why we're looping through these. Now let's go ahead and give this a try, and I'm going to show you that this actually has some form of an error. This is going to not work. And I'll just select any image. And it says, uh-oh, name error, name request is not defined. Now here's the tricky thing, and you're going to want to take note of this because moving forward, this is going to be a lifesaver. So the first parameter in add message is request. If we go back to our code here, in form valid, we don't have request. We have self and we have form. So how do we get request? We're in a form view here. Let's take a look at where request exists. Get, when you get the form. So when you're displaying the form, you could access the request there. Dispatch, HTTP method not allowed, options, post, and setup. And so what we want here is we actually want dispatch. So when this view is being dispatched, when it's about to be rendered, what is it going to do? And so let's go ahead and just copy this line. And because it has request in here, but our method in here, form valid, does not have request, what we can do is def dispatch self request args quargs. I literally just copied that from here. Def dispatch self request args quargs. Return super dot dispatch request args and quargs. And so literally at this point in time, we're saying, hey, Django, we know you have a dispatch method. I just want to let you know that I want you to use that dispatch method. Honestly, this is pointless, but it becomes less pointless when we do this. Self.request is equal to that request object. And because we're in a class, we can use self.request anywhere else. So now we can type self.request here because it's being accessed here. Dispatch gets run before form valid does. So it's going to set this for us, and then we can access self.request down the road. Let's go ahead and try this out. Let's just refresh this page, generate a new message. And I'm just going to grab any image, it doesn't really matter. And it says your post was successful. And that's coming from our base.html. It's in an unordered list. And let's right click and inspect this. We have a UL with a class of messages. We have an LI with a class of success, and in it has your post was successful. We have a UL class of messages. It's going to loop through every message. We've got an LI with message tag, message.tags. That was success. That comes from here. And then the message itself is your post was successful. It says the message in there. And that's all there is to adding messages. So really, all we need to do is type messages.addMessage. It takes a request. It has to take that exact request object. It takes some sort of message type or a tag. So we're saying messages.success because this was successful, and then our message itself. In our base template, because we want this to show up on any page, it doesn't matter where, we want it to show up on any page. We're going to say if there are messages, cool, loop through those messages and display them. Now watch this, when I go back here and I refresh this page, that message goes away. It's very temporary. It only exists once. Okay, let's add a front-end theme, and for this we are going to be using Bootstrap 5. So we're going to go to getbootstrap.com, and we are going to use, I'm going to be using version 5 beta 1. Maybe by the time you're watching this, we're on a different version. That's cool. It doesn't really matter. Let's just get started. We need this CSS. Let's go ahead and copy this. This is coming from a content delivery network. We don't need the JavaScript yet. I mean, if you want to, you can add it, but we're simply going to add the CSS. And we want to add the CSS on every page. So what we're going to do is simply paste it in here. And that's going to add it to every page. And that's why we have this base.html. It's going to add it to our detail page, our home page, and our new post page. And watch this. When I refresh, you're going to see it looks just a little bit different. Just a little bit different, hey? It just sort of resets things for us. Now let's go ahead and add a nav bar. And let's, I think it's in components. We're going to find it, nav bar. And let's find one we like and just copy that. We can always modify the HTML later. Which one do we want? Is there a simple one? This is a pretty simple one. This is a good one. So we have like a title, like image sharer, our homepage, add a post. And that's actually all we need. Let's go ahead and copy this. And because we want this on every page, we're going to throw this in our base.html. Now I'm going to get rid of a few things here right off the bat. Navbar, I don't want that to be called navbar. I want this to be called image sharer because that's what we created. And that's just going to go to the home page. So it just goes straight to slash. It doesn't need a special URL because slash is always the home page of a website. We could go to home. And again, that's just because the way we have this set up is we could use slash, or we can use URL feed index. And again, where that's coming from is if I close views.py, go to urls.py, feed index. That's going to give us a slash, same as up here. It just happens to be that it's, prefixable. If we wanted the homepage to be something like /home, that will automatically change for us. Features, we don't want pricing and we don't want disabled. And instead of features, let's call this add new image. And we need to link this to our feed post. And where that's coming from is feed post. And that's going to go to this URL here. Let's go ahead and see what this looks like. Maybe this looks terrible. I'm not really sure. That looks okay. I can live with that, I guess. Let's make this actually 100%. That's not bad. I can live with that. Now let's go ahead and center some of our content here. And we're going to say in our base.html, and let's maybe clean this up first. I'm a stickler for nice clean code. All right, so I just cleaned that up. And we want to center all of our content. So let's take a look at containers in Bootstrap 5. Customize content layout? Containers, that's exactly what we want. We want a container, maybe we want a regular size container. And so on an extra large screen, it's going to be 1320 pixels wide on a, that's an extra large. I didn't realize they did that. Now there's an extra large, 1140. A large is 960, 720, 540. Anything below that is 100%. Let's use a container. And let's see what this does. Cool. So that sort of centered it for us. That's good. Let's get rid of this link because we have that already in there. And where did that come from? That came from our home, I believe. Yeah, right there. Let's go ahead and get rid of that. Beautiful. And what we can do is this nav is actually taking up a lot of space. So what we can say here is includes /navbar.html. And let's go ahead and copy all of this. Not copy, but cut. We're going to go cut. And this is going to look in our templates folder for a subfolder called includes, and then a file called navbar.html. Let's do this. New file, includes, includes, spell it right, /navbar.html. Paste. And now our base.html looks nice and clean again. Let's just make sure that that's working. That is in fact working. Beauty, beauty, beauty. What else do we want to do here? Let's make these like cards or something. So what do we want here? I think that's called a component in Bootstrap. It's a card. Yes, this is exactly what we want. We want an image with some text and then a link to view the entire image. So let's go ahead and copy this. And we're going to throw this in our for loop on our home page. Our home page, let's go ahead and get rid of that. Let's get rid of that. And let's just make some space to work. And we just want to replace, like the image src with this image in here, or this text with post.txt. So let's actually go ahead and start doing some surgery. Let's go ahead and cut that and put it right into our paragraph. And that's going to be our text. We don't need a card title. If you wanted to, you could extend your model to have a title. So every image could have a title. Go somewhere. Where is this going to go? That's going to be this link here. And instead of say go somewhere, let's make the text say view full image. And then we need to move this thumbnail stuff down. And move that. And move that up. And what we need is that image URL. So we grab that image URL. And that alt could be whatever alt text you want. We're gonna throw away the image width and height. And we're gonna give this a class of card image top, which already came with it. So I guess we're not giving it, we were already given it. Let's go ahead and save this. Oh, and let's get rid of this old stuff up here. Clean this up, make it nice. So that people you're working with don't hate you for writing very sloppy code. Okay, not bad, not bad. These are all on their own line though. That's not quite what we're looking for. We want all of these to be a column. So let's go ahead and create a new row. And this is just knowledge from old Bootstrap. We create a row, move that div down. And then for every post, we want to create a new column. So we could do column SM. When it's small, let's take up 6.col md4, hit tab. Emmet automatically does the rest for me. Hey, not bad, not bad. Could be better, but that's not bad. And actually what I should do is I should take a look at the layout in here in the docs. Let's take a look at the grid. So we do have col SM. We just want to make sure that it works the same in Bootstrap 5 as it does in like Bootstrap 4, Bootstrap 3, etc., etc. Because I might have written the wrong class name. There we go. There's an example. Column large 2. That is just proof that what I was looking for was the right thing. So on medium, let's actually do 3. Let's make this a little smaller. There we go. And it needs a little bit of spacing above and below each card. And what happens if I get rid of this? Okay, that works all right. Under each card, let's do margin bottom 4. Let's do margin top and bottom 4. There we go. And look at this. We have a nice little image gallery. Let's go ahead and view this image. Okay, so you know what? The base stuff was applied. That was nice. Let's go ahead and clean this up a little bit. So let's open up our detail.html. And we don't need a go back link because that's now in the nav bar. It's in home or add new image or the logo if there was a logo. We don't need that anymore. The text and the image is all we need. And let's go ahead and make this responsive. And I don't know what that actually is in Bootstrap. So let's do a responsive images search. And we want image fluid. Class img fluid. Okay, not bad. Could be better, I think. Let's see what else we can do. We've got image thumbnail, cool. Rounded, is that what we want? Yeah, let's do that. Let's make the image rounded. I got really excited about that. Rounded. And that's just going to give us nice rounded corners. Let's go ahead and maybe throw this into some sort of row as well. Row with a col SM, let's say 10. So small and up is going to be a column width of 10. Move that up. And I think it's offset SM1. I'm guessing. Aha, it did. It centered it. And let's go ahead and add a padding to the top. Padding top is 5. That just bumps it down for us. And let's maybe add padding bottom 5. So on the left and right, we could do padding X, or on the top and bottom, we could do padding Y, PY5. And it looks like it did nothing, but added padding to the bottom down here. Last but not least, we have our post page. This page looks terrible. Let's go ahead and fix this. Might as well close those. Let's do new post and that button. Let's change that button. Class, BTN, success, I'm guessing. Cool, that worked for me. What do we have for forms? Okay, so this gets right into it, and we may not actually have all that control. We don't. Because a lot of this is handled for us inside of Django, we don't have access to, not easy access to the label. We actually can get access to the label and loop through all the form fields and create a form by ourselves. It's a little more advanced, so we're not going to cover that in Django 101. But what we can do is if we wanted to write some CSS, which we're not going to, but if we wanted to write some CSS, you could say everything inside of your form with, let's say, an input type of text could then be this kind of field. And you could extend it using Sass and things like that. We're not going to get too into that. Let's just make this page look a little more tidy. So let's add a class here. Class is going to be col sm4 offset. Quick math here, 12 minus 4 is 8, divided by 2 is 4, so this is going to center it, because there's 12 columns in Bootstrap. And let's add a title. Let's do an H2 in here. Upload an image. And let's add some padding in there as well. Padding top 5, margin top and bottom 5. And at this point, I'm really just experimenting to make this look half decent. I want that button to be bigger too. btn-lg. There we go. Now let's say we want to rearrange text and image. So someone chooses the image first and then writes text. Let's go over to our forms.py and let's simply rearrange this. I just move this up and down. So the first one's going to be image and the second one's going to be text. Save, wait for Django to reload, refresh. And there it is. Image first, text later. And let's say we didn't want to call this text, because we see it's called text here and image there. Image is fine, I think. Let's go ahead and change that label. Label is going to be description. It's still going to be text in the Python code, in the Django code, but the label is going to say description instead. So instead of text, right here, it's going to say, come on, load for me. Description. Nailed it. Just like that. Last but not least, when we upload an image, we have messages. We need to display a message. And so this often gets missed because it says, if messages, then do a thing. What we're going to do here is actually, we're going to design this outside of the if statement and then wrap the code inside of it. So let's go back to Bootstrap and let's do a background color. Background colors. Ooh, let's do a gradient. I like that. And so we can have text success. Ooh, look at that. We've got lots of them in here. BG success, because we're using success for a message. Info as well. Where's the gradient? Yeah, this is what we want. BG success and BG gradient. So let's go ahead and create a new bar in here. And let's just throw that in there. Let's make sure the text is centered. And the text is going to be white so we can read it. Dummy text in here. Let's just see what this looks like. Oh, look at that. It's above the navbar. That's too alerting. Let's move that navbar up. Okay, cool. Let's add some padding. Padding top and bottom is going to be padding y-axis. Let's do 4. Hey, I like that. I can live with that. Now we have to move this back into the if statement. And we can do the message tags. It's going to be here, because we knew that originally it was actually success. We're just going to throw it in there. And then we're going to wrap that in an if statement as well. Like this. And all I'm doing is a little bit of HTML surgery here. And that is a simple if statement. Then we can say else, as a default, always fall back to, instead of, maybe we didn't give it a message. Let's say it always has to default back to success. So it's saying here, if there are message tags, print those message tags. Otherwise, use success and if. We need to then move this message. And again, just doing some surgery here. Paste. And lastly, 4. Moving it down. And there we go. So now this says, if there are messages, 4 message in messages. Let's go ahead and style a div, put the message inside of it. And let's add a new image. And let's make sure that this actually works. Testing a Django message. Yeah, your post was successful. And I need to move that back up. And that will then move back down. Let's do one more example, just to really drive this home, just to make sure. Test message shows up in there, says your post was successful. Now, we have one more thing to consider. What if you have a brand new application here and nobody's using it? There are no images. Let's go ahead and delete all these images. So we go into posts, grab all of them, delete, go. Yep, delete them. Nothing shows up. Doesn't look the greatest, does it? What we can do is on our home page, because that's where we're looping through all of our posts, in our for loop, we can say, if it's empty, write stuff here. And it says write stuff here because there's nothing in there. Let's go ahead and add some styling here as well. So we're already in a row. We just need to add a column. So col sm6.offset 3. Let's make this text center and give it a padding top and bottom of 5, margin top and bottom 5 as well, lots of spacing. H2, welcome. Paragraph. Add a paragraph. Add your first image. And a button. href. We're going to fill that in just a second. Class is equal to btn, btn.lg, btn success, because we're going with a green theme here. Upload image. And we just need that to actually go somewhere. We know how to do this. URL, string, feed, post. Upload an image. Let's upload our first image. And let's do Gully 2 because he is super cute. This is Gully. There he is. View the full image. There's Gully. We are done our app just like that. Okay, welcome to your project. We just created an entire Django app from scratch in this course in Django 101. What I would like you to do is, if you haven't been following along, I want you to try to recreate this app from scratch. It's going to take a little bit of research. You might have to access the Django docs. You might have to access this beautiful website. It's actually not beautiful, but it's very, very informative. ccbv.co.uk, very, very helpful. You might have to access the Bootstrap docs. Might have to do a little bit of research. It's not going to be super easy, but it's going to be great experience. Or if you want, you don't have to necessarily do it from scratch. You can take all of my source code. You can always download the source code as well from github.com/calebtallien/Django-101. Make sure you follow the README. I'm going to write a README in there, and then you can just follow along. You can clone it down to your computer and set it up on your own, and then just modify it. I want you to make it look beautiful, make it look and act amazing. So we did all the back-end work. You can now just have fun with all the front-end work. And the front-end work is really, really fun. You get to make it really interactive, colorful, beautiful. You can make it look and do different things. But essentially, you should be having a project like this on your computer that takes an image, uploads it, and displays a thumbnail, and then we have a detail view in Django. Feel free to modify it to your heart's content.